Hello, hello. How's it going? Okay, I think this is good. Can everyone hear me? The obligatory, can you hear me? Can you hear me? I can hear you. Can you hear me? No, I can't hear you. We'll go back to the other set. No, anyway. Hey, how's it going? Tonight we're doing something slightly special, in that I'm doing like a whole class. I'm trying to come up with a new class format for these streams instead of me just working on whatever. So specifically, we're going to be working on several different small game projects. Let me punch up this. So about a year ago, I started working on a project at this URL, which I've just posted to chat, where I'm trying to come up with a lot of small games that are easy for beginners to wrap their heads around. Because once you've learned all the Hello World stuff and you know what a for loop is and that sort of thing, you start asking like, well, how can I get better at programming? And people tell you like, work on open source projects, which is terrible advice because most open source projects aren't very well documented. They probably don't have any like onboarding materials or documentation for new contributors. And also the code is just very can be very advanced and use a lot of techniques or just best practices and idioms that beginners wouldn't be familiar with. So I thought like, okay, I want to come up with something that's more than just snippets. So I thought I came up with a whole list of these sort of constraints. Like they should be under 256 lines of code. It's just an arbitrary limit. But this way you can understand how they work. They only use print and input, so just text output and input. That also makes them really easy to port to different languages. So, tonight we're going to be working in Python 3, but you could also make these same games in pretty much any programming language. All these programs don't require any sort of additional modules or libraries that you have to install. They all just work with the standard library, and I try to make them well commented. So tonight, if you go to, I have in the lower right corner a little thing that says the notes are at otbor.com slash class. And I'll be updating this file as we go on. Anyway, it's basically just like, hey, here's the URL for that has all the details about what I'm trying to accomplish here tonight. And also, as sort of like a giveaway here, you can go ahead and use this coupon to sign up for my online course, which I created in Udemy. It follows along with Automate the Boring Stuff with Python. Oh, yeah, and I guess I should do the obligatory plug of, hey, the second edition of my book, Automate the Boring Stuff with Python, is coming out. It now looks like it was pushed back a couple weeks to November 19th, I think, mid-November sometime. Um, but you can pre-order it off of the publisher No Stretch Press's website. I really like buying books off of No Stretch Press's website because if you buy the print book, you'll probably won't get the discount that like Amazon will give you, but you will get the ebook completely for free. It'll be PDF, EPUB, and Kindle formats with no DRM holding you back. It's just here's the file, which I think is really great. Let me close that. And yeah, so I kind of figure if you have questions, for one, I wrote this one blog post about like how to really ask effective questions, and basically because I get a lot of people who, the way that we're taught in school, we're often thinking about, oh, if you have a question, just ask. But with programming, oftentimes programmers who are online, it sort of grew up with an email culture where you want to minimize the amount of back and forth um, you have between the asker and the answerer, because it could be like I reply to that email tomorrow or in a few hours or next week or something like that. So you want to minimize the amount of back and forth. And so part of this culture is trying to figure out what have you tried on your own, what are the exact error messages that you're getting, what is your code, can you post that to like pastebin.com and share that, um, and a whole bunch of other, like, providing enough details so that the person who's helping you can actually help you. So I'm going to post that into the chat room. And yeah, so I kind of figure for the format, we're just going to be working our way through these 5 programs right here. They're all from that collection of games and little animation programs that I've been making. I'm just going to be typing in the code for all of these and explaining while I'm typing, sort of. And I'll just work my way through these 5 programs, and I don't know, if we have time left over, I'll just maybe go through some others. But anyway, feel free to go ahead and ask in chat if you have any questions about programming, or even if, like, I want to try to stay on topic, but we can also just like go off if you just have general questions, or you want general advice about programming or Python or something else like that. Okay, so I'm going to go ahead and oh yeah, so I'm assuming that everyone has a working install of Python 3. That could be you have something like idle, which I am putting up right here. Or something else. I'm going to be using a program called Sublime Text. I'll probably just be like copying code right here, and then whenever I run it, the output just opens up in a new tab right here. But whether you're using idle or the Mu editor or PyCharm or anything like that, it's pretty much all the same. Okay, so the very first thing that I'm going to work on is this zigzag program. And I'm going to cheat real quick. Let's kind of take a look at this code. This is a fairly short program. It's like 20 lines long or something. I'm just going to copy and paste this. Oh, and I do insist that you like actually type out the code yourself. Don't ever copy and paste it, because actually typing it out sort of makes you carefully consider what exactly you're typing. It's a nice way. I don't know. It's otherwise, if you just copy and paste it, you'll be like, okay, there's code, and then you run it, and then you see that the code runs and everything. But it's hard to just sort of develop that memory of like, oh right, I wrote some code that was like this before, and then that's basically how you can learn a lot better if you actually type out the code yourself. But just for demonstration purposes, I'm going to show you what this program looks like. It basically prints out a big zigzag forever. Now, this is a general like command line program thing, but it's also true in Python. If you ever need to cut out or like stop a program, you can generally hit Control C. Unless you're using Sublime Text, apparently. Okay, Sublime Text does not want to stop that. Okay. Sublime Text has some weirdness with it sometimes. So I'm going to be running Python from the command line here in Windows. And it basically looks like this. Oh, live performance, of course. Yeah, typing out stuff even if you're copying it from Stack Overflow, that's a good idea as well. Great. Okay, well, first problem. Now let's start debugging things. Let's see. This is a command line program that prints out the source. Okay. So yeah, that is the program. And now Python zigzag. But that does nothing. Interesting. How about if I run a different version? That is so weird. Okay, so I have... So, which is a Linux tool. What the command is where on Windows, it just shows you like what runs when you type. This is weird. Windows apps python.exe. Okay, well that's strange. It doesn't matter. I'm just going to be typing pi, which is a convenient program on for the Windows installation of Python. You can then type 3.8 or 3.7. You can run whatever version of Python you want. And if you don't enter anything, it just runs the latest version that you happen to have. I don't know how this got added to my path environment variable, but that's okay. Zigzag. Okay, and now you can press Control C to stop your programs. Control C, please work. Yes, it did. Excellent. All right, so I'm going to be cheating and I'm going to be looking at my second screen for the actual code for all of this. But so it's kind of artificial, but I feel like it makes it a lot easier for people to follow along with me if I run code this way. So first thing I like to do is really just type a little title and credits right here. Maybe some contact information like this. I actually don't do this in most of my programs, but for this collection I am, because I'm kind of aiming it at like young adults and I want them to think like, cool, you can like put your name on it and show your friends and things like that. Let's have like a one-liner description right here. So these are comments. The Python interpreter completely ignores them. They're just for our own, the human programmer's benefit. And just like a little reminder to myself, press Control C to stop the program. Hey, let me just increase the size of this so that it's a bit easier to see. Okay, so let's think.
You have a new follower.
Oh man, I still have that voice set up. I should probably. No, I'll leave that. I'll leave that up. Hey, new follower, Zunjin. Thanks a lot for following. So this program, let's see. We have basically we're always printing out.
You have a new follower.
How many? 8 of these asterisks. Hey, Mountebank. Thanks for the follow. So first of all, we can kind of see like, oh yeah, it's a zigzag pattern. Let's try to figure out what the pattern is behind this program. You can see we always print out 8 asterisks. It's just that we seem to beforehand be printing out more and more spaces, one more each time, before the asterisk, causing it to slide to the right. And then once we get to a certain point here, I think this is like 20 spaces, then we start decreasing the number of spaces by 1 character until it gets down to 0 spaces right there, and then we go back over this again. So let's think about what this looks like. Oh, let me go ahead and close that and close that. So I'm just going to start like saying, hey, we're going to need some sort of while loop that just loops forever. So I'm going to have while true right here.
You have a new follower.
And this will just be the main program loop. And I guess, first let's think about what we want to have happen. We want this to zig to the right like 20 times. We'll just keep like adding 1 more space each time. And we'll have some code there. And then I'll just say we'll zag to the left 20 times. So, I mean, let's think about this. So I want to print out 1, 2, 3, 4, 5, 6, 7, 8 right here. Now I want to have an increasing amount of spaces. Now I could do something like this, just hard code this. This is called hard coding, and generally it's not ideal because you don't want to have to program every single step that your program does. That can take a long time, especially for like giant programs and stuff. In fact, I have one really egregious example of this. Here, this is my first tic-tac-toe program. I'll just put the Thanks a lot, chat. I'll put the link to it in chat. So this is my first tic-tac-toe program. where, if you're a beginner, you might write a tic-tac-toe game that you play against the computer as this. And it is 18,000 lines long. It has no loops in it. It's just a bunch of print. And it shows you like, oh, enter these numbers for where you want to move. And then, hey, if the player moved one, well, then you mark their space right here. And then you put the computer's move right there. And then you ask them again. And basically you hard code every single possible game of tic-tac-toe against a computer. And it comes to be about 18,205 lines. Now, of course, I didn't write this code myself. I wrote code that wrote this code. But yeah, you don't want to do that. I'll admit the first time I was like, hey, I got this clever joke idea for a program. And I thought like, oh, I can just like copy and paste it. And I quickly realized, no, I have to write a program because even if I like copied and pasted this all the time, it would still just be way too much work to do. So you don't want to hard code stuff like that. Instead, try to figure out what the pattern is here. So we have a certain number of spaces. So we could say, hey, we have like spaces, and we'll use string concatenation here to combine these together. And what's the pattern with the number of spaces here? Well, one thing that we can do is do string replication to create strings of varying sizes. So string replication in Python is when you multiply a string by an integer value, and that evaluates to a string that has that first string replicated. So for something like a space, if we want to have 20 spaces, we'd just type single space character times 20. So we want to multiply this by something. I'm going to go ahead and close this. Sorry, I'm going to try moving this around. Hey, where are cases where preprocessing is something you'd want to do? So by preprocessing, you mean like calculating things beforehand. So let me go into, let's say this. There's times whenever you're writing code where you could write code in one way that saves a lot of memory, but it takes longer to run. It's like doing some clever tricks to save on memory. So you're sacrificing CPU time for memory savings. Or you could use a lot of memory and that would save you time and make your programs run faster. It depends on a case-by-case basis. I know one thing where this is kind of going into a different topic. What was it called? Generate prime numbers or something like that, or crypto math.
You have a new follower.
Hey, new follower. Hey, Pound Cake Cake. Thanks for the follow. Let's see. Oh man. So I had someone like prime number generator. Rabbit Miller, I think this is. Oh yeah, so I have this one function, is prime, and you pass it a number and it returns true if that's a prime number or not. And normally the way prime numbers are numbers that don't have, you can't evenly divide it by any other integer. So for example, I don't know, like 21 is not prime because you can divide that by 7. Whereas 23 is, because any number you try dividing it by is going to have like our little remainder fractional part of it. The only numbers you can evenly divide it by are 1 and itself. And so you can do this, you have to like basically go through all the numbers, like constantly dividing everything. Technically you only have to divide it by the first few prime numbers. And I have like a little section right here where I have this variable called low primes where I've pre-calculated like all the prime numbers under 1,000. And so instead of going like 2, 3, 4, 5, 6, 7, 8, 9, 10, and for actually you don't even have to do that because it's only going to be 2 and then odd numbers. So you could go from 3 to 5 to 7 to 9 But like, you don't have to divide it by 9 to check it, because if it was evenly divisible by 9, it would have been evenly divisible by 3. And so that's why you only have to divide by 9 prime numbers. So I can, it turns out you can actually get a lot of CPU savings just by using these first several dozen prime numbers. Um, so, like 1001, let's pretend that's a prime number. Um, or like, actually, let's pretend it's not a prime number. Then I would have to like divide it by that, even though technically I wouldn't have to. Anyway, I'm sort of rambling at this point. Um, Long story short, the
You have a
choice,
new
it depends
follower.
on what your requirements are. Whether you want to make something fast but eat up a lot more memory, or make something save on memory. Maybe you have like lots of different instances of this program running, so you don't want to eat up all the memory or something like that, or you're trying to make it run on like a small microcontroller and you're limited on memory there. It depends on your situation. Anyway, and hey, Blorpy Robot, thanks for the follow. Okay, so the pattern, we're gonna want to have like a variable right here that keeps track of how many, let's call this indentation maybe. That sounds better. How about like, oh, indent size is what I used. So this will replicate, this is basically how many spaces we're going to have because we multiplied this number by this string. And then we concatenate it with that. So indent size, that's going to start off as 0. Let's make a comment. How many spaces to indent? And so another thing when you're writing code is oftentimes you will be writing it just sort of all over the place. I'm not just like starting at the top and then spitting it out fully formed. You'll go back and forth a lot. That's totally normal. One great idea is to sort of stub out with these comments, like the different sections that you need to write. That helps you sort of like break down this massive problem into a much smaller problem. Okay, so let's think about this. So we're going to have this. I mean, if I ran this, this doesn't do anything except get stuck in an infinite loop. Yeah, that's not very helpful. So we want this to increase. So maybe inside of this, we can just have indent. Indent size equals indent size, the current size plus 1. Oh, and that doesn't really work either because this keeps going increasing without bounds. So we want this to only happen like a certain number of times. Hey, if we want to have something increase do something a certain number of times, that sounds like a great idea for a for loop. Let's have this. For I in range 20. And I'm going to indent this code right here. So this actually doesn't solve our current problem because, okay, well, we do this 20 times, but then we're still inside this infinite loop right here. So how about, let's do this. Let's create another loop right here. And here we're going to be decreasing indent size. And then I'm just going to copy the code that we already have.
You have a new follower.
Whoa, okay, so that's super fast. Hey, computers are fast, who knew? Let's add a tiny little pause to that. So we're going to have to import the time function, or the time module. Hey, thanks, new follower. Hey, Courageous Kokiri, thanks a lot. So I'm going to add a slight pause to all of these. A very, very slight pause, but it will make all the difference. About like 1/20th of a second. So that's what, 50 milliseconds. Pause for 50 milliseconds. Now, this is an example of kind of like not a great comment because it's just sort of reiterating what the code does. But since I'm making these programs for people who are sort of beginners at programming and they might see like time.sleep 0.05, what does that do? And this explains, oh, well, this is a number of seconds, so this would be 50 milliseconds. In real world production code, you're probably not going to have comments like this because they can also quickly get out of date. Like, let's say if we decide to change it to this, now the code says, oh, we're pausing for 100 milliseconds, but the comment says 50 milliseconds because we forgot to update that as well. So generally you want comments that tell you why you have the code doing what it's doing instead of like what the code is doing. Or you want to have like little summarizations like right here. So I'm going to add this right here as well. Hey, Blurby Robot. Yeah, well, get a text editor open and follow along. Let's see. Oh yeah, and we can also run these for loops in the Python interactive shell. So the interactive shell is a really helpful thing. It's also called the REPL, R-E-P-L, because it reads an instruction, evaluates it, or rather executes it, and then prints out the result, and then it loops back so that you can enter a new instruction. So the interactive shell is really good for just experimenting and playing around with individual lines of code. So you can be like, hey, how does the print function work? Oh, and I was like, oh, okay, it works like that. One thing for multi-line instructions, like a for loop, you can see that the prompt changes from the triple angle brackets, which is usually called a chevron, to 3 dots. And let's see, we're going to have to indent right here. And then run a bit of code, and it'll always like give you another ... prompt. It won't finish and run the code that you've entered until you enter a blank line. So here it just prints out hello 20 times. But what I like to do, and it's Control Z on Windows to quit, I believe. Yeah, and then Control D on Linux and Mac to quit if you're running inside of a terminal window like this. Let me go ahead and run this program again. Python zigzag. Hey, look at that. It's working great. Now we can hit Control C to stop this program. There are a few things that we can do to make this a bit easier to read. I'm a big fan of adding variables to make code easy to read. So like this looks kind of confusing because when you see the asterisk and plus operators, you're generally thinking of math, even though we're not doing any math right here at all. We're doing string replication and then string concatenation right here. And it's weird, I don't know, like maybe we could add more parentheses to make it clear that this is creating a string and then we're concatenating it here. Here's another idea though. I'm just going to create a new string called indentation.
You have a new follower.
Oh, hey, Ansen01, thanks for the follow. And then I'll just move this into a separate variable, and then we can just add that variable in here. And I'll do the same thing over here. I know I said don't copy and paste, but I'm doing that right here anyway. Oh, indentation. So now it's a bit easier. It's like, oh, okay, so we're taking this indentation string or whatever, and we're adding it to this string. What is the indentation? Oh, it's a certain number of spaces, the number in indent size. So we haven't actually changed what this program does, but we have made the code a little bit easier to see. Now, I believe this is the entire program as I've written it. I'm just thinking like off the top of my head, other things we could do. We could, for example, set up some constants. Um, like, how about this? I want to make it easy to change this number, but I'd have to change it in two places. So how about let's just create a constant variable, which by convention has all is written in all uppercase letters. This is by constant, it's still a variable just like any other Python variable, except the uppercase means, hey, we're going to set this, don't change the value in this anywhere inside the code. Only let's have it as a setting up here. So I could say 0.05 and then just change this to be delay. And now if I want to later change the speed of the program, or like the amount of delay here, like let's say I want to make it much, much slower, like 10 times slow, I only have to change it in one place and the rest of the program gets updated automatically. This is really nice, especially when you have code where, what if you had this in like 30 different places or like 500 different places? You don't want to go through and change all of those individually, because not only is that a lot of work, but you're also likely to like forget one or two places, and then you have your code sort of out of sync, and that can cause a lot of problems. Let's see, at first I was missing the crucial space in between quote in the indentation variable. Right, yes.
You have a new
Yeah, if
follower.
you have this, you'll get something different. In fact, we can take a look at it in the interactive shell. So let's just play along like, hey, what happens if I multiply this by 20? Oh, that's interesting. What if I multiply this by 20? That is also interesting. But what about the blank string? What happens if we do string replication on a blank string? I mean, you could guess, but usually it's just easier to open up the interactive shell and then type in the answer. And it's like, hey, a blank string, it's sort of like multiplying like 0, I guess. It's just the blank string. Yeah, and if you end up doing that instead, you'll get a bug right here. Oh, and I've also slowed down the program as well. So it's not zigging or zagging. So hey, we could just like play around. What if we had like plus signs in here? Ooh, that's interesting. Let me increase the speed again right there. You can see how like quickly you get used to making small changes and then running the program. So now instead of spaces right here, I have like all these plus signs. That looks kind of cool. Okay, I'm going to change that back to plus space. Hey, you know what? This is again like not something I have like written in the online version. We could add another. How about let's just call it indent character, because we could then set it to like anything. So indent character. So we could have it as a space right here. And then say like, I want to make this a dash character. And we could see how that looks. So a lot of programming is writing your code in such a way that makes it easy to change, because that's the main thing with software. It's like the one constant is that we're always going to want to change it. We're either going to want to fix bugs, and so we're going to have to like read the code and understand it and to make changes to fix a bug, or we want to like add a new feature to it, or just like make small changes like, hey, I wonder what it looks like when I have little dashes instead of spaces. Okay, so that's pretty cool. I'm gonna go ahead onto the next program. Oh, right, yeah. You bring up a good point. Also, for these, I wrote this code this way just so that I don't throw too many new concepts at beginner programmers. But this indent size equals indent size plus 1. This is a really common thing to do in programming, so much that there's a lot of languages have a little shortcut like this. Um, I mean, right here we're saying, hey, I want indent size to be equal to the current value of indent size plus 1. So, we want to like change it based on its current value. This is so common that we have a new augmented assignment operator plus equals, and it just looks like that. So this does the exact same as before, but it's a little shorter. It's easier to type, easier to read. We can do the same thing right here, minus equals. And this code runs the exact same way. In general, less code is better because the fewer lines of code you have, in general, the fewer moving parts and complexity you have, which means there's fewer things to break. Hey, variable plus equals variable. That's interesting. What happens when we do that? Like, let's say, I'm just going to call, let's say we have a variable spam. Let's say what happens when we have this, spam plus equals spam. Well, I guess really what this is doing is the same thing as spam plus spam. So it's kind of just doubling it. And if we run that again, it's 4. And then if we run that again, it's 8. And then 16 and 32 and 64 and 128 and 256 and 512 and 1024 and 2048 and 4096 and 8192. And then I forget the 16K one. You start picking up on like powers of 2 a lot when you program. Next program. Continue testing. Let's see. Well, okay, if I go to the class notes, which is that URL that's in the corner there, otbor.com/class. Okay, next one, rock, paper, scissors. Oh, and again, just as a reminder, hey, everyone watching the stream, I'm Sweigart. I create a bunch of free programming materials, including available today, and it's good for 3 days, but I created it like earlier today, so like the next 2.5 days you can sign up for the online course that follows Automate the Boring Stuff with Python with this code. Let me go ahead and like post that to the chat room. Yeah, it's October OCT 2019 free. Tell all your friends. And go ahead and sign up like today, even if you're not planning on taking the course today, because it gives you lifetime access for it. But the sign up for it is only good for the next like 2.5 days. Anyway, hey, okay, let's take a look at this. Paper, rock, scissors. I'm going to cheat and just copy paste this. Or rock, paper, scissors. And this is what this program looks like when we run it. So it says rock, paper, scissors by Al Sweigart, little email there. Gives you the rules to rock, paper, scissors, just in case you've been living under a rock and you don't know the rules to rock, paper, scissors. Rock beats scissors, paper beats rocks, scissors beats paper. And then it shows you how many wins, losses, and ties that you've had. So you get to enter your move. Either like, I have these little parentheses right here, so you can say like R, P, or S, or Q for quit. So I'm going to say rock. It's rock versus paper. You lose. Okay, and then you can play again. How about paper? Paper versus scissors. I lost again. Let's go with rock. Good old rock. Never lets me down. Scissors. Hey, I won. And you can just basically keep playing this over and over again. So notice we have like a little like delay here just to add some dramatic effect. It doesn't just immediately tell you like you win, you lost, or something like that, which is totally just like a user interface trick to, because This kind of goes back to earlier chess programs. I'm not even sure if this story is true, but it's a good story where some chess program way back in the 1980s or 1990s when chess programs were coming out and it was like a big deal, like, oh, computers can play chess. Um, where people would play against the computer and then they would lose because computers are really good at playing chess. But what was really like like infuriating about it is that you would take, like 30 seconds or 2 minutes to figure out your move and you would make a move and the computer would instantly respond um, with a move that like take some piece of yours or is like some really clever setup for a strategy or something. And it's really frustrating as a human being to be playing this game where you have to work so hard and the computer just like has it happen instantly. So what the chess programmers did was that they added artificial delays to the computer just to make it seem like, oh, the computer's really crunching those numbers and trying to come up with a move. It's, you're really good at this game. We're doing the same thing right here. So I'm going to enter P for paper, and it has like a little 1, 2, 3 delay right there. Um, this is a fairly simple program because there's like no strategy really involved in it. It's just kind of dumb luck, but it is also a short and easy to write program. So, it's entertaining for about 5 minutes. Yeah, so this is a completely new project. Go ahead and start a new uh, blank file. Oh, the other thing to keep in mind is that, hey, not only can we enter like lowercase r for rock, but we could also enter uppercase R for rock.
You have a new follower.
Oh, hey, Mr. Blade Brown, thanks for the follow. Oh, and also explosive, thanks for the follow. And also, I think I have
You
it set
have a
so
new
that you can
follower.
enter like the full word as well. Oh, no, just one. So another thing with these programs is I want to make it impossible for the user to
You
crash
have a new
them
follower.
by entering bad input. Hey, new followers, Cloyvin and Joyspot. Hey, thanks for the follows. Or JSpot. Thanks. So, if you enter something like that or something like the letter U, it'll give you a
You
message
have
saying,
a new
hey,
follower.
type one of R, P, S, or Q. And I'm just going to press Q for quit. Hey, Danello 2020, thanks for the follow. All right, so to begin, just going to start off with like a little title explaining what this program is. And like a little credit thing right here and like my contact information for anybody who finds this. Okay, next, I'm going to try importing a bunch of things. So there's a bunch of modules in Python's standard library that I want to import. Random is going to be one of those because we have to randomly pick paper, rock, scissors for the computer. We're going to have those like little dramatic little mini pauses there, so we need the sleep function in the time module. And then also we want to exit the program by pressing Q. So we're going to have to be able to pass call sys.exit. So a nice thing about using a text editor with plugins like this one is that I'm running what's called a linter. Things like PyCharm or Visual Studio Code have these built in. With Sublime Text, I had to find a plugin and then configure it. But it will point out any like things that are like small problems or possible bug causing problems as you type code. So for example, right here, you probably can't see it because I'm blocking it, but it'll say random imported but unused. So it can just do static code analysis to not find all bugs, but it could find like really common typo type of bugs. In this case, it's like, hey, you imported random, but you don't actually use that module anywhere in your program. You can take this out. But it's appearing right now just because I'm writing out the code and I haven't gotten to that point yet. So hey, let's go back to this. Remember all this? Oh yeah, I printed out a little title right here
You have a new
along with
follower.
instructions. So I'm going to go ahead and print that out as well. Rock, paper, scissors. Oh, and Fernograss 89, Gara 89. Thanks for the follow. And butchering people's screen names is something that I do a lot. Sorry about that.
You have a new follower.
Uh, Celia, thanks for the follow.
You have a new follower.
And also dumb intel. Wow, a lot of new followers. I might not have time to like thank everyone because I also like want to stay on track. It's also weird because on my second screen I have like the chat room on the right side of the window and then the names of the followers on the left side, but I also try to have my source code that I'm copying from on the left side. Sorry about that. Let's see, I just want a blank line right here, so I'm going to have an empty print. And then all the rules: rock beats scissors.
You have a new follower.
Paper beats rocks. And scissors beats paper. Hey, Tester Choice, thanks for the follow. All right, so next, what do we have? So, I mean, I'm using the output from the actual program, but when you're designing your own little games and stuff, you could just like keep track of like what exactly you want it to do, or like, I think it's helpful to actually like type out what you would want it to look like. That can help you sort of organize all of your thoughts. Okay, so next we print out how many wins, losses, and ties there are. So I'm guessing we should create some variables to keep track of that. So let's have the number of wins and losses and ties in variables with those names. And we'll set them to 0 because it's at the very start. We have 0 wins, 0 losses, and 0 ties. Just add a comment right here. These variables keep track of the number of wins, losses, and ties. Hey, ZeroCon. Hey, thanks a lot. Yeah, I'm not actually looking to get partnered on Twitch, really. Most of the time, whenever I stream, um, I'm trying to just mostly focus on whatever project I'm working on, and if I have an audience, then I can't like goof off on social media every 5 minutes. All right, so I'm gonna have a main game loop right here. So this is just gonna be an infinite loop, and like whenever the player presses Q as their move, then it will like break out of this loop and stop. Probably won't even do that. I'll just call sys.exit, and that pretty much does the same thing. Pyflakes is complaining because I've like set up this loop, but I haven't like typed out the actual code for it. So let's go back to that output and like, what did this do? Oh yeah, first of all, we would always do the same things over and over again. We would print out the current score. We would ask them to enter their move, and they would enter their move. And then when we would do that, your move versus, with a 1, 2, 3 little dramatic pauses, we would announce the computer's move, and then we would display the results of the game. And then you can see right here, well, this is just the exact same thing right here. So that's the pattern right here. It's basically in these lines. And we had a little bit more than that because if you type something that it couldn't understand, it would then display the whole like, oh, you need to enter R, P, S, or Q. So let's do this. So first things first, we want to display wins and losses. And then also when they enter their move. I actually see a typo with like the code that I have, but it's fine. So notice the thing here, like when I run this game. Oh, whoops, haha. That's right, I already deleted this, so I can't run it again. Notice how whenever I entered, let's see if I can find it. Yeah, one of these things right here, like a bad input right here. would say type 1 of RP, S, or Q, and then it would just loop back again. So there's several ways that we can implement this. Let's go with like a loop inside of a loop. So I'm going to say while true. So like whenever I'm asking for input, I usually like to do that inside of a loop. So that way if the user enters bad input, we can just like loop back and ask them again and just like keep asking them until they've entered a valid move. So I'm going to say, hey, keep asking until player enters like rock, paper, scissors, or Q. So let's display the score. And so I'm going to use f-strings. F-strings are a feature that are new in Python 3.6, I believe, but I really like them. They basically work like this. Normally we would have to do like name equals Al. And I would have to write code like this, hello plus name. And so this is string concatenation, but you could also do it like this. Hello %s, and then you have a %, followed by like a tuple or something like that. And that would also work. And that's really useful if you have like multiple things in various places. Your name is %s, and I can just have name and name right here. But f-strings, this has a bunch of plus signs in your code, and that makes it hard to read. This %s thing is kind of hard to read because you have to like look over to the right and then back to the left and sort of match everything up. F-strings are nice because they put everything sort of in line. You just have to have an F prefix before the first quote. And then you can use curly braces to put in any sort of code or expression, and whatever that expression results to gets injected inside that string right there. So that is really nice. Or you could also say like age. I am 24 years old. And then you could have a string that says, hey, next year you will be, and then we can have curly braces right here, age +1 years old. And the nice thing about this is it's automatically converted to a string, whatever value you have, so you don't have to type something like, like stir around all of this like that, because it's just done automatically. So it's really nice. I really like f-strings. It's great. Let's use that here. So let's say for the number of wins we have, it's going to be the number inside the wins variable. Wins. Losses, this many losses, and this many ties. Oh, now if you literally want to use oh, hey, C# also has that. Yeah, a lot of languages in like last few years have adopted this practice. It's really nice. If you ever do need to actually use actual curly braces in your string, you can't really escape it, but you can do double curly braces. And so now this is literally printing out that text. Okay, so next, wait a second. Did I like? I'm gonna paste this code into chat just so that people can make sure people have it to follow along with. So I'm printing out like here's your score, and I'm also going to ask you to enter your move, and just to help them like understand what type of input I'm expecting from them, because they could type in anything.
You have a new follower.
Oh, hey, Sea Monster, thanks for the follow. So I'm going to say rock, P for paper, S for scissors, or Q to quit. And let's see, I want to call input. So that lets the player type in something and press enter. And I want to save that to a variable called player move. Now remember, I had it so that you could enter either like lowercase r or uppercase r and it would work the same. Here's how we can do that. We can take the string that they type in and let's call the upper string method on that. So this evaluates to the uppercase version of the string that they typed in, and we store that in player move. This way we only have to compare it to like the uppercase version of RPSQ. We don't have to do like two separate comparisons for uppercase R and lowercase r. Benefit of Sublime Text. Sublime Text starts faster and is generally kind of simpler. I tend to work on much smaller projects, so I don't really use a full-blown IDE like PyCharm all that often. Okay, what was I doing? Okay, so we have the player's move. Next, we need to make sure that it is correct, if it's like R, P, S, or Q. In fact, the first thing we can do is like, well, we can just check, hey, if player move is uppercase Q, so even if they entered lowercase q here, it gets converted, upper will return a capital Q for player move. And in this case, we can do sys.exit. Hey, I'm coming up with all sorts of ideas for small changes, so I'm going to be making those in this little like notepad thing off screen. Um, So if it's Q, we'll exit. Otherwise, we have to make sure that it is R, P, or S. Now, one way we can do that is just say, hey, if player move is equal to R, or player move is equal to P, or player move is equal to S, in that case, it's valid, so we want to break out of this loop. So we can just run this break. Yeah, Sublime Text is basically free. It will just occasionally like show you a like nag screen when you start it up until you buy a license for it. I use it so often that I kind of figured like, okay, I've been using this software for several years now. I guess it's worth the money to pay for it. Um, Now, one really common mistake that I see people making is that if they want to compare, like if player move is one of these three values, they'll type code like this, which is really sinister in how easy it is because notice how the linter is not complaining at all because this is totally valid Python code. Here, let me go back to the interactive shell. Let's say we have player move is equal to something invalid, so blah, 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 blah. Now notice when we run this code, this should result in false because player move is not equal to R or P or S. So none of those cases are true. This should be false, but it comes out as P, which in the context of an if statement, which is just looking if it's a truthy or falsy value, that's going to be true. It's not going to be false. And the reason that is because you have to think of it as kind of separated as this. So this kind of makes it a little bit more easier to see. So remember how OR works. Only one of these has to be true for the entire expression to be true. So Python first checks this, player move equals R. That is false because player move doesn't equal R. So then it goes on to the next one, which isn't, it doesn't have like any comparison evaluators. There's no like equals equals or less than or whatever operator there. It's just p, and any string that's not the blank string is going to be a truthy value. So it says, oh, okay, so this is true, and it's going to evaluate all of this as just this expression p right here. What you really want to do is this. Oh, whoops. And what you really want to do is copy and paste this correctly. So now it's actually checking, we've set player move right here, if player move is equal to R, or if player move is equal to P, or if player move is equal to S. Now this can make this really huge. So the common Pythonic thing to do is to write your code like this: player move in, and you can just create like a little tuple of all the values that you want. So that's like saying, hey, if this value here is in this tuple of values, then evaluate to true or false, based on whether it's in that or not in that. In fact, we can even say not in as well to get the opposite. Hey,
You have a new follower.
Oh, Honeyfugler, thanks for the follow. What's the difference between a string with single quotes and a string with double quotes? In Python, absolutely nothing. It's down to preference. I prefer to use single quotes because I don't like holding down the shift key whenever I'm typing the quotes, so it's a lot easier. I do notice that there's a tool called Black for Python, which will automatically format your code according to like best practices. And one of the things that it does that I don't like is that it changes all your single quotes to double quotes. But if you're working on a large project with a bunch of other people, you don't want to be like arguing over code style issues like that. You can just say, hey, we're just going to use the Black tool to automatically format all of our code. That's fine. Yeah, so I mean, Black is really great. The things I don't like, I don't like everything about it, but that's probably a sign that's a pretty good compromise. But yeah, in Python, you can use single quotes or double quotes. Hey, Ernest, thanks for the. Hey, hello, thanks for saying thank you. Now, in other programming languages like C++, these are different data types. If you have like, this is called a char. It's been a while since I've done this, and I think this is true in Java as well. It might be true in C#. I don't actually know C# except that it's basically Java with some other features installed. This is char, which is basically like a one-character string, whereas the double quotes are used for multi-character strings. I guess technically they can also be like one-character strings as well. Python basically says there's no real difference between that, so let's just have strings use either. Oh, why do I use sys.exit instead of exit? That's a really good question, and because I remember I thought of this as well, or I found this and I was like, yeah, that is weird. So when you're in the interactive shell, or like in idle or something like that, you can type exit, and this will exit automatically. It pretty much... This has got to be like the most common typo I ever make. I always call it import sys. So sys.exit seemingly does the same thing. So like, why do you bother doing like the import sys and jumping through those hoops? And the reason is because technically this exit thing is only valid inside the interactive shell. Whenever you're running programs right here, actually, you know what? I'm gonna check this to make sure before I like shoot my mouth off. Print hello, but I remember it was something like, oh, exit. That's defined when the interactive shell starts up. You can see when I type exit by itself. Normally, if I don't use the parentheses, it's not calling it. It's just like, hey, here's the function. It says, oh yeah, that's a function. Whereas exit has like a nicer looking string little message here. It's not even a string value because you don't see quotes or anything like that. And that's because, if you're starting with Python and you fire up the interactive shell, you're like, okay, how do I quit? you might type exit and then I'll say, oh, use exit or control Z plus return to exit. I think the same thing with quit. Yeah, quit is also set up like that. So like what happens if you're not using the interactive shell? Well, test1.py, you can see it does, oh, I guess it does do the same thing. Huh, that's weird. How about if I just have this? Can I print this? Does this have like a string representation? I guess so. That is, hmm. I remember maybe they changed this, or maybe I'm just remembering it wrong. But exit, I always remembered like, oh, exit's something that's only set up by the interactive shell, but I don't know. Let's go ahead and look that up. So, here's what professional programmers do like 20 million times a day, and that is Google for stuff. Python, sys.exit versus exit. And as
You
usual,
have a
like
new
the
follower.
first 3 or 5 search results are all for this website Stack Overflow. And this is why Stack Overflow people are really like kind of hard about uh like trying to get rid of all duplicate codes, is because they ideally there's only one search result that comes up, so that the different answers aren't split up and duplicating people's work. And you can see like with this question is protected because people keep saying like commenting thanks and me too, and Stack Overflow also tries to make their website like just the question and just the answer without like any extemporaneous fluff or something like that. Um, is a helper, and then yeah, so sys.exit is intended for use in programs, but it seems like exit works anyway. Yeah, okay, so I have nothing but superstition. Here's for the actual official documentation. And when called, raises system.exit. Oh, yeah, something about the site module. The site module is imported automatically during startup, unless we do -s. Oh, okay. So I guess if you're running some like production Python program and you want it to be absolutely super fast, you would include this -s so that it doesn't import this site module. So like if I have this, but then I run this by saying, hey, Python py-s, well, no, it still works. I don't know, but I'm old and curmudgeonly, so I'm just going to keep doing sys.exit, even though there's got to be like some weird use case where it doesn't work. But yeah, I guess you could just run exit. Oh, do I do -s at the end? No, because this is an option that you want to pass to Python itself. If I did this, this would be passing -s to my program, which you can see. Import sys print sys.argv, this list of options, like right here. You can see that's being passed to the program itself, whereas this -s is being passed to Python, which is then running your program, and then there's no command line arguments for your program, so that's why sys.argv is only set to this. Yeah, there's probably like a bunch of cleanup things that sys.exit does that normal exit doesn't do. Um, hmm. Anyway, hard hitter. Hey, thanks for the follow. Oh yeah, and I tend to use DuckDuckGo for my search engine. Just because it's a company that's like much
You
more
have a new
privacy focused
follower.
than Google is. Um, and for the longest time, it took me like a long time to finally make the switch. The actual switch to get your browser to just use DuckDuckGo by default instead of Google. It's like 30 seconds. Um, and the search results are pretty good. I've never really, I don't know. I'm sure like maybe once or twice I've looked at DuckDuckGo's search results and been like, let me see what Google finds because maybe it can find whatever I'm looking for. But for the most part, yeah, I just use DuckDuckGo. So I kind of encourage everyone to also make that switch. Uh, Additivity, thanks for the follow. Right, rock, paper, scissors. So if they enter a valid move, then we break out of it, out of this loop. So break and continue only apply to the innermost loop. Uh, Otherwise, what we want to do is just print out some like correct instructions. Like go ahead and tell them type one of R, P, S, or Q. And that'll be it. So it'll print this, it reaches the end of this while loop and goes back and asks them to enter their move again. uh, yes, Python does have scope. I was actually talking about this with a friend earlier today because she's a programmer from, I believe, mostly like C# and stuff. And Python's kind of confusing. Hey, let's go ahead and have yet another random topic to talk about. Let me find. Let me try to
You
find.
have a new follower.
What was I called this file like scope example or something. Python scope example.py. Oh yeah, there we go. So let's talk about Python scope. This is probably a good thing for like intermediate level Python programmers. But first off, let me say thanks for the follow to Golden Beat. So Python does have scope. Usually there's like a few more rules, but the basic scopes that you have to really think about are global scope, um, where something is, or I guess like module level scope is the more accurate term, really. But that basically means, hey, your variable is assigned outside of every function. Um, so really, it's where this assignment statement happens that tells you if a variable is global or local. Now remember, so in Python you can have multiple variables with the same name. Think of them like as identical twins, where their names look the same, but they are in fact two separate variables that can have two separate values. So here, spam, this is referring to a global variable named spam. Now inside this first function, we have this assignment right here, spam equals local. So this is a second variable um, that can exist at the same time as this global spam. However, inside here, whenever we refer to spam, we're referring to the local spam variable. So this is going to print out local right here. So that seems like fairly obvious. Things that you should really like keep in mind are like local variables are sort of like created when you call the function, and then they get destroyed when the function returns. So if we call func1 two times, it's going to create spam, set it to local, print it out, and then destroy that spam. And then the next time we call it, it's going to create a new variable, local, and then print that local variable out. So the contents of these local variables don't survive in between calls to the function. It's kind of like how these global variables don't survive in between runnings of the program. Like when your program exits, all the variables get forgotten. If you need to save your work to a file or something like that, because whenever the program closes, all of that data is gone. So you can think of functions as like a mini program inside of your program. Okay, so next example, this spam is a local variable because it's all parameters are local variables. You can see like when we call this, we provide something with spam. Spam is necessarily a local variable. So in this third function right here, notice how there's no assignment for spam. So like here in function one, we have this assignment statement right here. So that tells Python, hey, this is a local variable named spam. Here, it's going to say, well, there's no local variable named spam, so let's check if there's a global variable named spam and use that. And if it turns out there is no global spam either, then this is going to cause an error message. But we went ahead and defined it like up here. Whoops. So as long as this like def statement executes, or if we call function 3 like after this line, that tells us like, oh, okay, yeah, there'll be a global spam variable that uses it, that this is going to use. In general, this is kind of not so good. You want to avoid using global variables inside your functions because it's much easier to reason about your functions and the code inside your functions if they're sort of like isolated from the rest of your program. Like here, this function only uses local variables, or this one right here. So all I have to worry about as far as like inputs and outputs to this function is like, hey, there's a spam parameter, and we can pass arguments for that parameter, and then we return some value as the output. But in this case, there's sort of like a hidden parameter in the global spam variable. So if we have a bug that's inside this function and it's because of the spam variable, like right here or this one, we know like, oh, okay, if there's a problem with the spam variable, it's probably due to code somewhere in this function. There's like one place that we have to check.
You have a new follower.
Here, we're going to have to check our entire program because this is a global spam variable. So any code anywhere in the program that changes spam could have potentially changed it to some invalid value that caused a bug. So that's why when people say like, oh, don't use global variables, it's because it's sort of like a hidden parameter, and now you have to like pay attention to the rest of the program. Like anything anywhere else in the program could have changed this spam to an invalid value that later caused some bug. Now this is an interesting case. In function 4, this is a local spam. However, we use it before we assign it, and this is going to cause a bug or cause an error inside of Python. Oh, hey, also, Jaded, thanks for the follow. So to determine if a variable inside a function is global or local, Python, when you first call this function, Python's going to be looking throughout the entire code before it starts running the code, and it'll find like, it'll see if it can find an assignment statement for this variable. And so it sees it right here and says, oh, okay, spam equals something. Spam must be a local variable. And then it starts running the code inside the function, at which point it'll say, hey, print spam. Well, this obviously refers to the local variable spam because spam is a local variable in this function. I previously saw that somewhere in the function, it's right here. So it's not going to fall back and use the global variable. It's just going to say, hey, this is a local spam, but we haven't actually defined it. Oh, in fact, the linter is smart enough to pick up on this. Local variable spam defined in an enclosing scope on line 7, referenced before assignment. What that basically means is like, hey, you need to swap the order of these. And so in function 5, this whole thing, that's true no matter what. Remember, it's just looking in the function to see if this assignment statement exists anywhere. It doesn't matter, like in this case, the assignment never actually happens. I have if false right here, so this line is always skipped. So this assignment never takes place, but that doesn't matter. As long as there is an assignment statement somewhere in the function, Python is going to consider this variable spam to be a local variable. It's not going to use the global spam right here. So that's actually kind of helpful because it's not like you have to look through this code yourself because like, oh, spam, this could sometimes mean local and sometimes mean global in this function. Inside this function, a variable's either going to be local or it's going to be global. Now, the exception to all of that, like here in function 6, we have an assignment statement for spam. So that means, hey, it should be a local variable. There's an assignment statement inside this function. That means spam is local. But no, no, no. We can also have a global statement saying, hey, I know I assigned spam right here. Spam refers to the global variable spam, not a local one. So this is when we print spam right here, we're going to be printing out this message right here. This global spam variable's value right here. Oh, hey, Matchstick Boy. Yeah, see you later. Let me catch up on chat. Oh, how do you access the local variable of a function in a main function? Ooh, that's really good. I will get to that in a second. But yeah, global statement says this is a global variable. So this is printing out the global variable spam, and this is making a modification to the contents of the global variable spam. Now, like, so let's say I want to modify the local variable from outside this function. That is actually completely impossible. And you might think like, oh, that's like, oh, I really wish I could do that. But you have to, I'll go ahead and explain call stacks, and that makes everything like so much easier. And you can see like, oh, yes, logically that should be impossible to do. This is really just going off script. Hey, remember when we were making rock, paper, scissors? So let's create, actually, let me, hey, here's like a talk that I gave at a conference on recursion. Right. So, function calls work with something called a stack. Because remember when you, here we have like an A function and it calls B, and the B function calls C, and C function calls, it doesn't do anything. It just says, hey, here's the start, here's the end. And then we call A at the very start. I don't know, is my head blocking? Yes, here we go. We call A to kick things off right there. And then here's the output. It'll say start of A, because we start A right there. Then the execution goes here, prints out start of A. Then it calls B, which means the execution moves here, prints out start of B. Then it calls C, and then that moves it down here, start of C. So that's why you see start of A, start of B, start of C. And then it prints end of C, which is why we see that. And then it goes back to this line and continues from there. So this says print end of B. That's why we see this right here. And then this goes back to the line that called it, and then says end of A. And then this goes back to this line and continues with the rest of the program. So the thing to keep in mind is that the execution doesn't go on a one-way trip. Python keeps track of what line called that function, so that way the execution can return back there. That's why we see this sort of backwards behavior right here. Start of A, start of B, start of C, and then end of C, end of B, end of A. And this is all managed with something called a call stack. You can think of it like if I'm having a meandering conversation, kind of like this whole stream. We're like, hey, I'm telling you a story about my friend Alice. So like I'm talking about Alice right now. The top of this stack is like the current thing I'm talking about. And telling you about Alice reminds me of a story about my friend Bob, so I start talking about Bob. And then that reminds me of a story about my friend Carol, so I start talking about Carol.
You have a new follower.
And then I finish the story about Carol and then get back to talking about Bob. And then I finish my story about Bob and then get back to Alice. Hey, ABC, notice how it sort of parallels this right here. Functions work the same way. There's a stack data structure, meaning that, and a stack is a data structure where basically you just add and remove the topmost item off of the stack. Um, a stack is first in, last out, because notice how, like, if I'm talking about Alice and I put Alice in first, and then I put Bob and Carol in, and then start removing Carol and Bob, Alice is the last thing that I take out. So the first thing in will be the last thing out. A queue is first in, first out, where the first person who gets in line will also be the first person who gets out of line because they get served first, and then they can like leave the line. Meanwhile, like the person who enters last at the line is the last person to get out of the line. Um, but yeah, that's if you've ever heard those terms before. A stack is a uh, philo, first in, last out, or LIFO, last out, first in. Anyway, so when the a function is called, that information gets stored right here. These little boxes are called frame objects, and they'll keep track of oh, when I return from this function call, I should return to this line. It'll like remember the line number. And then A calls B, so P gets put on the top of the stack. The topmost frame object is where the execution is. So like B is executing, then C is executing, and C finishes. So when we return from a function, we go back to the next top, which is B, and then we return from B and we go to A, and we return from A, we go here. So really the global scope is whenever there are no frame objects or no function calls on the call stack. Hey, let me catch up on chat. Hey, Matter Dash. Yeah, hey, I'm Al Sweigart. I wrote Automate the Boring Stuff with Python. Um, is there a topic we're doing? Yes. So I have a little URL in the corner that says class notes or notes, um, which originally, well, here I can just hotboard.com/class. Um, well, originally we were like working our way through all of these, and we're currently typing up the code for rock paper scissors, and then I got distracted. Hey, just sort of like I was talking about rock paper scissors, and then now I'm talking about call stacks. So I'm gonna finish talking about call stacks, and then get back to rock paper scissors after that. So yeah, conversations do follow that stack data structure. Unless you're talking to me, in which case I just talk about topics randomly, but I try to have some semblance of order to them. So yeah, you can see when no function has been called and the execution isn't inside any function, the call stack is empty. So any variable that's assigned when the call stack is empty, well, the execution is outside of any function. So that's like when global variables are created. Now for local variables, on the other hand, those are created inside whatever function call right here. How can I think about this? So each of these boxes are called frame objects. That's just the computer science term for it. They contain like the number line to return back to, but that's also where all the local variables are stored. So remember how I said functions are like a mini program inside your program, and just like how when your program terminates, all the variables are forgotten. Well, when your function call returns, all the local variables are forgotten, because like, let's say we set some variables here inside of C. When C returns, all that gets deleted along with everything else. So basically, I mean, I guess it is technically possible. Like if we were at this point where the stack looks like this and our code is currently executing inside the C function to like change some of the variables inside B or A, but that it's sort of like using global variables where you're starting to I mean, this is set up this way so that's very isolated and segmented, and it's easier to reason about. You kind of don't want to change local variables. But anyway, like after C returns, all those local variables inside the C function get erased because they're no longer needed. So it's not like the code inside B could change the variables inside C because the C function call, the frame object for the call to C doesn't exist. So it's like there's nothing to change really. Um, Another thing to keep in mind with the call stacks is that each of these frame objects, they don't represent a function, they represent a call to a function. And so this is from my talk on recursion. And I point out, like, the thing about recursion is that you have functions that call themselves. So like here, like, oh, A calls B and then B calls C. But for this like factorial recursive function, factorial is calling itself, which is kind of really like flips your noodle, bakes your noodle. It does something to your noodle. Um, because what you also have to consider is that, there are local variables that exist independently and separately inside each of these frame objects. And that's something that's really easy to forget about when you're just like looking at this code. Technically, this local variable number, there's a separate number variable in each of these function calls. So when factorial calls factorial, that's creating like separate number local variables. Anyway, this is a huge talk. I think there's. Let me go ahead and find like This talk is up on YouTube, I think. Yes, recursion for beginners, a beginner's guide to recursion. And then I also, I guess I gave a shorter. I think this one at North Bay Python was probably the best version of this. And then I gave like a 3-hour tutorial, which I didn't quite like as much as the shorter talk. But yeah. Let's see, catching up with the chat. Isn't using a global statement always a bad idea? In general, it's a bad idea, but like the global statement exists because, it doesn't necessarily have to be a bad idea. If your program gets really, really large and you start using global variables everywhere, that can make it harder to reason about things because the code inside your function is no longer just using local variables, it's using global variables, which means code anywhere inside the program that modifies the global variable could be affecting stuff inside the function. Whereas if you had a function that only used local variables, you can be really sure that the problem only exists inside that function. It's basically like the earlier that you can detect a problem in your code,
You have a new
the
follower.
better. Oh, Zabrian and Matterdash, thanks for the follows, as well as Nostoska and Jaded. I think I doubled up on Jaded with the thank yous there, but thank you anyway, and thank you a third time. Let's see. Yeah, so, I mean, there's a lot of superstition when it comes to programming. I mean, you see this yourself, like, oh, my computer's acting weird. Turn it off and turn it on again. I don't have time to like figure out exactly what's wrong with it, but turning it off and turning it on seems to like fix most problems. And you really can't well, you can sometimes get away with that in programming, but for the most part, if you have some bug in your program, there's a logical reason for it. It's not just something random. I mean, it could be some like really hard to track down race condition that only happens under very specific circumstances, and it's really hard to find out what those circumstances are. But there is a problem with your code. So we tend to like come up with these rules of thumb, like, hey, don't use global variables, and don't use global variables gets repeated over and over again, and we kind of like stop thinking about why do we have that rule. It's sort of like, Grog got eaten by an alligator when he walked into that swamp. Don't walk in that swamp. And then like a century later, it's like, hey, we don't walk in that swamp. Why? Well, we've kind of forgotten the reason why. But just don't do it. Maybe that's still good advice and still relevant. Maybe not so much, or like maybe the alligators only come out at night. I don't know. That's a weird metaphor that I just came up with. But yeah, using global variables is totally fine uh, for most small programs, for programs that you're just like gonna throw away. Like
You have a new
unless you're
follower.
unless you're writing code for like a bank or a nuclear reactor or a Mars rover or like a Martian bank's nuclear reactor, you don't have to like strictly abide by that. Like in Zigzag, man, I use all of these are global variables technically. I don't have any functions at all. Same thing with this. Yeah, so um, for people who are just like joining us, I've been or I've been creating this Git repo full of small little games. They're designed to be easy for beginners to follow and understand with, just to have like an idea of what programs look like. Let me go ahead and get the link for that as well. Oh yeah, it's in that class notes URL, right? Oh, I guess I don't have that up. Let me edit that right here. Do 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 do. Type 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 type. And edit. Okay, so if you go to that otbor.com/class, you'll find this. Sorry, this is just like a random text file that I'm putting up notes and updating as we go about with the stream. Hey, does my videos on demand get deleted? They shouldn't be. I've signed up for like Twitch Turbo, so they should be up for like a month or however long. This particular stream, I'm planning on doing some light editing and cleaning up the audio so that I can post it to my YouTube channel. So it'll be available there. Oh, also for new people who are just joining us, I have a coupon code offer. Okay, let me paste that GitHub link. You can sign up for the online Udemy course. It's like a 10 and a half hours of videos across 50 different videos that basically follows the content, most of the content in Automate the Boring Stuff with Python. This code lets you sign up completely for free, but it's only good for like the next 2.5 days. So go ahead and sign up for it. Even if you're not planning on getting to it like for several weeks or several months, it's fine. It's at your own pace and you have lifetime access to it. So go ahead and sign up for that. But yeah, so I have a bunch of these programs right here, and we're just working through a small selection of them. So yeah, let's get back to that. Uh, yeah, I do. I write full time. This somehow I suckered the universe into letting me do this full time. So as long as I can keep writing about this whole programming fad, uh, I won't have to go back to getting a desk job. Let's see. Also catching up on chat even more. Do you just know Python? No. I mean, it's mostly Python that I've been working on for the last 14 or 15 years. Wow. Yeah, I got into Python around 2005, maybe a little bit before that. But I've the other languages like JavaScript, I guess, is the main one that I last worked on professionally. Um, but I also have done work with like Java and PHP and Perl and Visual Basic and C and C++. I really want to learn, well, I want to learn C Sharp just because I would like to dip my toes into the Unity framework to like, I have some like small ideas for like 3D games that I want to make. But two languages I really want to get into are Rust and Kotlin. Um, but I just don't really have time to like get into that right now. Anyway, okay. Rock, paper, scissors. We have variables to keep track of how many wins, losses, and ties. This basically, all of this code is basically so that we can get a player move variable that has valid input. It's either R, P, or S. If it's Q, then we've already quit the program. So at this point right here, player move should be set to a capital R, P, or S. What else happened? Right, so after the user entered their move, it would print out like rock versus, or like paper
You
versus,
have a
or
new
whatever
follower.
they entered. Hey, Johnny5, thanks, and Colored Binary, thanks for the follows. It would display this. So we want to display this next. So let me. Oh, yeah, that's that code. That's fine. Sorry, this is a bit artificial, but I'm just copying the code off of stuff here. So that way you don't have to like type along with me. You can also just look at the code in this link to copy off of that as well. But oh, Juicy Sword, where's Python used in the real world? Pretty much everywhere. Python has like conquered a lot of places. It's probably, like data science, analytics, DevOps, and like, which is like a fancier term for like sysadmins who can program, as far as I can figure out. Web applications, definitely. Um, I think like even some desktop applications, just server stuff as well. It's really good in a lot of different domains. I think it's probably easier to say where it's not used rather than where it is used. And that's mostly like gaming. Like you can use Pygame. Um, and PA also has a game module that's built on top of Pygame that they can talk about if they want. But oh yeah, it's also used as a scripting language in game development. Really? I always thought that was Lua that mostly had a lock on that field. But I mean, I guess you could use MicroPython as well if Python's like memory footprint was too big. But anyway, yeah, gaming, like microcontrollers. So like if you have a chip on a car or something like that, usually those are very low memory environments. Although like Raspberry Pis are cheap enough these days, and you can write Python for Raspberry Pis. So you can also do that. Oh, and Adafruit has a whole bunch of MicroPython projects as well. MicroPython is basically just a version of Python that's meant to work in very low memory platforms. And then mobile is the other big one. Although like the Beware project, Ware, like Bumblebee, has a lot of stuff that's trying to make strides for getting Python apps on Android and iOS. Oh, I didn't know that Mass Effect used Python. Yeah. And even still, like there are like more than a few games on Steam that are created entirely in Python. Okay. Python for mobile kind of fizzled out. Yes and no. Yeah, Russ and like lots of other people are still working on the Beware project. And there's also Kivy, which I've been meaning to look into for creating mobile apps in Python. I think Kivy is only on Android though and not on iOS. Anyway, let's go here. So the next thing we're going to do is like, we want to print like, rock versus, is that it? Yeah, it kind of looks like that. Or have something like paper versus, or scissors versus, except, so this is can see we're duplicating this code, which is something you want to avoid doing. You want to avoid duplicating code because remember, we're always trying to change and update or expand code. And if we have duplicate code, then we have, two or more places where the code is doing the same thing. And then we have to update each of those places. So we update code a lot. So we want to have it not be duplicated so that we have only one thing that we have to update. And the way that we can deduplicate, yeah, that was a term at some company I worked at before where it's like to get rid of the duplicate code. Um, we have to sort of take a look at it and figure out what's the general pattern for it. And then we can sort of generalize this. So, hey, this is really kind of the common thing that we want to do here is have this player move. Now the problem with this though is that this is only R, P, or S. It's not the full word rock, paper, scissors. I could do something fancier with that. Actually, when I'm looking at my notes, it turns out, no, I just kind of make this code really simple. Yeah, also that's another thing. It's like global variables. Duplicate code also itself isn't necessarily bad. In fact, you can go too far in the opposite direction where you find this code here and this code over here is the same. Let's put that into a function because we shouldn't have duplicate code. And you can try to keep generalizing stuff, but code that's more generalized can also be harder to read and reason about because it's very abstract and has all these parameters and things like that. So my rule of thumb is, you write code once and then you make a copy of that code a second time, and that's fine. But maybe after the third time you've made a copy of that code, think about trying to get rid of that duplicate code. But this is supposed to be a program for beginners, and I just want to make it as dead simple as possible. So I'm just going to duplicate this code. It's fine. Oh, and here I'm going to save this for later. So let's have this. If player move is R, we're going to print out rock. Oh, yeah, DRY is the acronym. Don't repeat yourself. If you didn't hear that, the acronym is DRY. It means don't repeat yourself. So here, if player move is equal to P, we want to print out paper versus, and we put it in all caps to make it look important. That's how you can tell text is important, if it's in all caps. Not rock, paper, socks. No, rock, paper, scissors versus. Okay. And now we want to have that dramatic pause part. Oh, hey, catching up on chat. Yeah, and feel free if I don't end up answering your question, reposting it a couple minutes later. I might have just not caught up about it. Oh, so Andrew240 says, what about a switch case? Python doesn't have a switch or select statement, and this is actually a good thing. Select statements are kind of terrible. I think, okay, so I'm just guessing here. It's kind of nice to know enough about different programming languages to kind of make a theory of this. So a switch statement. So normally in something like Python, you would have if spam equals
You have a new follower.
Do some stuff. Else if spam equals B, do some other stuff. Else if spam equals C. So there's a lot of repeated code right here. You're sort of typing the same thing over and over again. Hey, Go210, thanks for the follow. Yeah, the dictionary would be it's a really common. I don't know. I like to say that the dictionary way of handling this is the most Pythonic way, but I could see other people like arguing against that as well. But let me explain what I'm talking about for everyone else. Um, this is like a really common pattern. You have the same variable and you want to compare it to different things, but you also like what if we wanted to do this code like right here? Um, so what a switch statement does is it usually looks something like this: switch spam, and then this is actually not valid Python code at all. I'm just kind of using it as an example. You would then have like a case statement. So if spam is equal to A, do this. If spam is equal to B, do this. If spam is equal to C, do this. But then you would also have to have break statements at the end of each of these. Because if you took out the break right here, like let's say, hey, if it's B, I want it to do. Oh no, I'm sorry. If it's A, so this is really confusing. If it's A, I want it to do this stuff, but also do the same code in the B place. So you would take out the break statement, and it would fall through to the next case, and then it would hit break, and then exit out of this entirely. A super super common thing bug. Oh yeah, yeah, and then you could have like this would be sort of like your else right here. You would have default, and then it would do a bunch of other stuff. But a super common bug is people would use switch statements or select statements and forget to type break, and then your code would inadvertently run the code in the next case. Um, uh, this is this is such a common. It's a foot gun. It's a gun for shooting yourself in the foot. I think Python made the right call by not having something like this. But people are like, oh, but you know, what if you want this fall through behavior? Then you can use a switch statement to do that. I don't know. You don't. That's not really that common. I don't come across the need for that a lot. Most of the time, you're doing something like you're using a switch statement so that you have to type less code because otherwise you have to do this: if something, else this, something else if something else. Um, but like forgetting the break is super common. The compiler or the interpreter, there's like no error message that will come out if you forget the break. I think probably like a linter will probably point out like, oh, you forgot the break right here. I mean, it's so common that programmers would oftentimes like leave
You
a
have a new
comment at the end
follower.
saying, like, the lack of a break is intentional. This isn't a bug, something like that. Because if you're reading through code and you see like, oh, you forgot the break right here, like it's it's more likely that it's a bug that it was supposed to be there and it's not than that it's intentional and that it's not there and it's not supposed to be there, if that makes sense. um but yeah, so this whole thing doesn't really work, and Python doesn't really have this. Now if you want to do something like this in Python, yeah, I'll write the code right here so we get all the fancy syntax highlighting. um I don't know. I'm not even sure I would use this like dictionary way of doing this, um, because for like
You
this,
have
the
a new
code looks kind of
follower.
weird. Just go ahead. It's a lot of redundant typing, but using a bunch of ifs and else ifs is probably the most straightforward, readable way. But you could do something like this. Hey, let's have a dictionary. Um, Also, speak of Reek and Quiet Hitman, thanks for the follows. Let's see. We'll have this. Yeah, I kind of don't like this at all. We have like all the different cases along with like the values that the variable could be set to right here. And then at the end of this dictionary, um, you have player move. So if we think about this, we're going to call print. What are we going to print? Well, we have this dictionary that we immediately afterwards, like you rarely type this, like the square brackets after the curly braces of a literal dictionary in your source code. Well, okay, depending on what player move is, we'll find the matching key for that and then use the value of that key value pair. So if player move is P, then all of this evaluates to this key value paper versus, and that's the string that gets returned to print right here, and then that's printed. I think that this code is far more easier to read, even for like professional experienced programmers, than this code. And you know, in my next book, I talk about using this process. Maybe I should just take that out entirely. um, or just add like a note saying, don't actually do this. But yeah, this requires a lot of typing, but like, you know, you type code once. Like typing isn't the slow part of programming. It's figuring out what code you need to type. And also reading the code that you have previously written. You know, you only write code once, you read it over and over and over again. So it's really important to make code readable rather than easy to type. But yeah, Ningato, I'm new to Python. I would not have understood that print statement. Yeah, it's like you read this, like you can read this as like, oh, okay, yeah, player move is this, then do this. But if it's this, then do this. That's fairly straightforward. If you look at this, you have to like stop and take a moment. It's like, okay, what are we doing? We're printing. We're printing out a dictionary. No, we're not actually printing out a dictionary because we have this right here. So player move, this is the key. So then this player move is equal to these keys, and then that's the value, and then that's the thing that gets. That's a lot to like hold in your short-term memory. Um, so don't write code like that. Okay, so after we had rock verses or whatever, let's see, count to 3 with a dramatic pause. With dramatic pauses. Now I could write like a loop to do all this, but you know, like this is only 3 cases. I'm just gonna copy the code right here. So let's have like a half-second pause. So that half-second pause comes after this, and then we'll just type 1 and 2 and 3. My head is probably blocking that code down here. But we also want to have like small pauses. How about let's make it like what is it? A quarter of a second in between. So we have this print, half-second pause, 1 quarter second, 2 quarter second, 3 quarter second pause. And then we have to print out what the computer picked. Let me go ahead and stub out the rest of this. So display what the computer chose. We're also going to have to like randomly pick what the computer chose. And then so that'll display like what move the like rock, paper, scissors that the computer chose. And that'll be completely random. And then we have to display like the results and then like update the amount of like wins, losses, and ties that you had. So let's say display and record the result, the win, loss, or tie. So that seems kind of nice. Let's do, yeah, display what the computer chose. So let's have random number equals random dot random. There's actually multiple ways, you know, there's always multiple ways that you can write any program. Like, let's go back to the interactive shell. Import random. So random is really good for games. You can call the rand int to get a random integer, and I can say from 1 to 3, including 1 and 3. So each time I call this, it comes out with a random number. We could also call the choice function, and we pass that like a list of values, so a list of string values in this case. And this will randomly choose one of these and select this. I'm not going to use random choice, random.choice. I forget why. I think it was because I wanted to have an example of like how we get a random integer of 3 different things and then we pick something based on that. Was that it? I don't know. I guess so. Again, all these programs are made for like beginners, so I try to choose like simple, conceptually simple ways of writing this code, as opposed to like, oh, there's some like advanced function that you can call inside the Python standard library to do this. Like randint is the function in random that everybody learns. So I didn't want to go into like choice or shuffle or any of those things. But so if we have a random number, so this is set to the integer 1, 2, or 3. So let's say, hey, if random number is equal to 1, so we have player move. Let's have a computer move. We'll set that to rock. So it's kind of, I mean, it's almost exactly like this. So random number is a variable that contains 1, 2, or 3, but computer move is a variable that contains a string that actually describes the move. Because we can't just say, oh, the computer chose move 2. Like, what does that even mean? So we have to have like this code right here so that we can display something sensible to the user. And then if random number is equal to 3, we have computer move equal to scissors.
You have a new follower.
Hey, Sir Adaox, thanks for the follow. Okay, yeah, this seems good. Let me make a note. So previously we said, hey, rock versus 1, 2, 3. Let's go ahead and print out the computer's move. So we've displayed what move the computer has made, but now we need to actually like compare the computer move and the player's move to see if it's a win, loss, or tie for the player. So that's what we can do right here. So now we can say, hey, if player move, so I mean, there's 3 possible moves to the player and there's 3 possible moves for the computer. 3 times 3 is 9. It feels like there's going to be like 9 different like else if clauses that we have to code. However, we can do a little shortcut by saying this, hey, if player move is the same as computer move, then it's a tie. We can just say print, it's a tie. Ties plus 1. Again, we could also do that augmented assignment thing, but I just wanted to make it simple right here. Hey, Shadowman, what resources do people usually use to learn idioms, best practices, etc. in Python? So my go-to answer for that is these 3 books. Effective Python is really good. And I think it's also coming out with a 2nd edition soon as well. um, Python cookbook, which can really help you like learn the standard library and a bunch of things. But I think the best book is Fluent Python. Fluent Python is also like 5 million pages big. I really like Effective Python because it touches on a lot of the same topics as like Fluent Python does, except it's not nearly as big of a book. But I don't know. I'd probably read them in this order too. Let me copy and paste that. Um, but yeah, there's also a Doug Hellman's. Let me try to find it. Python module of the week. His blog, let's see, for Python 3. So this is great. He basically goes through all the different modules inside the Python standard library. These are like all the modules that come with Python. And then does a nice little explanation of each of them. And he did like one a week until he had basically gone through all of them. So that's super cool. You can read, he does a good job explaining all of these as well. So that'll tell you about the Python standard library for like idioms and best practices. Those books that I posted are pretty good too. Ah, pardon me. Yeah, I'm going to be posting this to YouTube as well. So the reason that I have this little slash right here is that this is an escape character. It basically tells Python like, hey, this quote isn't like, it's not the ending quote for this string value. It's actually literally a part of the string. So we say slash. If you literally need like a slash, like you have like a string that says like it's a green/blue shirt, you can put 2 slashes here, because otherwise this looks like, you know, it's an escape character for /b. But no, I just want to have a slash right here. Oh yeah, you could totally do a double quote right here. And then Python's smart enough to realize, oh, okay, well, the single quote's not going to end this string because it began with a double quote. Of course, like any double quotes you have, you would have to then escape. You can also just have triple quotes, in which case you don't have to escape either, unless you had like 3 quotes in a row that also met. Anyway, I don't think it's that big of a deal to just have the slash right there. So there's a slight problem with this in that technically computer move is set to like rock, paper, scissors, and it has to do that because it's printing out rock, paper, scissors. But player move is only going to be one character because when the player typed in their move, they just entered the first letter, and then we just displayed rock, paper, scissors here. So let's go ahead, but that means that player move would be the letter R, whereas computer move would be like rock. So this would not be true, even though they both went with the rock move. So let's go ahead and update. You know, we could change computer move to match player move, or player move to match computer move. Let's do player move. Let's just update that. So here, if player move is set to R, we're going to set it to rock. And same thing here. If it's paper, if it's P, we'll set it to paper. If it's S, we'll set it to scissors. And Chan, thanks for the follow. Yeah, a lot of programming in like these high level languages, I guess even like in assembly and stuff too, you know, there's more than one way to do things. So people just sort of write code however they want, how, you know, in whatever way that they prefer. It's totally arbitrary. Probably it just has to do with like whatever way that you learn to program is probably the way that you prefer. Although you can certainly have long arguments that go nowhere about like which is the best style or something. Okay, so now we have to go through. Let's go through all the win cases. So let's say if a player chose rock, this is nice. So this takes care of three of those cases. Like if player and computer were both rock, or if they were both paper, or if they were both scissors, it does the exact same thing. And we could say if player move is rock and what computer move was scissors, then we would print you win. And we would also increase the value in wins by 1. Now I'm going to go ahead and copy and paste this twice. And then just start changing this because we also need to cover the other cases where the player can win, and that's running the exact same code. So we could say if the player move was paper and paper beats rock and scissors beats paper. Now again, one thing, we have duplicate code right here, so that could be a sign like, oh, maybe we should get rid of that duplicate code. And we can. We could do something like this. Maybe, I don't think these parentheses are strictly necessary, but I'm going to type them anyway. So we could do, hey, if this condition or this other condition or this third condition, then we'd want to print you win and wins increment wins by 1. So this is kind of nice in that we don't have duplicate code here, but then we have like this line, which is super long, and I think the like standard is what 79 characters, which is what this ruler I believe is set towards, or 80 characters or whatever. I actually think that's like way too small. I prefer 120 because it's 2019 and we have large monitors. It's not like the 1980s where we have like a CRT that is only 80 characters wide. But as you can see, this is still even like too long for me. So I think it's actually a lot better if we just go ahead, undo, 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 undo. And you know, even though it does mean we have this, it's a bit easier to read and reason about. Now, oh, let me redo all of those changes. Technically, you could also do this. You could have a slash at the end of your code. Actually, I think for this syntax, it doesn't. Oh yeah, it is necessary. Yeah. And having a slash at the very end of a line is a way of telling Python, hey, pretend that this is all one line of code. And so that way it makes it easier to read on the screen, and you don't have the duplicate code. However, again, this is I'm making these programs for like beginners, so I feel like it's fine if I like use global variables or if I sometimes have duplicate code. You could argue I'm teaching bad habits, but I don't know. Let's make it simpler is better than complex. Yeah, pull the Zen of Python out on people. That gives me authority, right? Ah. Let's see. Catching up on chat. Let's see. It's a very good app. What app? Dumb Intel says, couldn't I just, instead of changing player move, couldn't I have just done like this? Sorry, rather, computer move. Yeah, so let's pretend if player move was still just a single letter R, P, or S, we could have just done this. Yes, technically that's also totally doable. That would work. I didn't do that just because I wanted to make this like program easier, and like I thought like, well, if beginners see this code, they're gonna be like, wait, what does that mean? And it's like a potential stumbling block. and I wanted to get rid of as many of those as possible. At least for like the really, really simple games, like rock, paper, scissors. But yeah, you're totally right. Let's see, Chen 20, super new to coding, waiting to get enough money for a laptop. Um, oh yeah, there are like some apps. Pythonista, yeah, I've heard of that. I mean, I guess that's, I don't know. I think I played around with it a little bit, maybe. I'm not entirely sure though. But yeah, there's a free website called pythonanywhere.com that lets you basically run Python apps like remotely on their servers through a web browser. And so that's something that like you could use as well. And Jupyter Notebooks works on mobile. I think so. Yeah, it can, but it needs to be configured. Yeah. Yeah, I mean, the one bit of advice I get for picking a laptop or a
You have a
computer
new
to do
follower.
programming on is like any computer is good. Like you don't need a fancy laptop at all to do programming. Um, like you could have a 10-year-old laptop. That's more than adequate for modern programming. It might be a pain because like the operating system in general is kind of slow, but there's I mean, you could also possibly find like a desktop that someone is getting rid of or something like that and use that as well. Because there is a ton of electronic waste that the computer industry generates. Hey, Putz92, thanks, and Wombat Combat 07, thanks for the follow. Cool. Let's see, I have. Let me just make some more notes for myself. Okay, so we have code that handles a tie. We have code that handles a win. Let's also write code that handles a loss. Oh, let me scroll this up a bit. Okay, so what if the player chose rock? How do I have this written in the actual program, which again is just right here, posted to chat. Okay, so if the player chose rock, we're handling the loss cases. So if the computer chose paper, we're going to print you lose. And then we're going to increment losses by 1. And we can go ahead and just copy and paste that. And then just change this to if the player chose paper, and if the player chose scissors, and then if the computer chose what cuts paper? Scissors. And if they chose scissors, if the player chose rock. And I think that's it. So once we reach the end here, we're inside of a loop, and so we go all the way back to the start of this main game loop, in which case we do the whole thing where we ask the player for their next move, either rock, paper, scissors, or to quit the game. Now, theoretically, this program works perfectly, but let's go ahead and... I don't have to run it because I know it's perfect, but let's go ahead and test it anyway. Rock, paper, scissors. Here we go. Displays the instructions. 0 wins, 0 losses, 0 ties. Let me test, like, if I enter bad input. Always a good thing to test. Like, not just the things you expect to work, but you need to check the unexpected inputs as well. And so, yeah, it says, okay, yeah, type one of these letters. So let me type test out quit, and that does quit. Okay, cool. Let me run this again then. Rock. Rock versus rock, and it's a tie. And let me just be careful to check. Yes, it is ties that increments by 1, and wins and losses are still at 0. So you try rock again, and paper. You lose, and that increases the losses. Now, if you want to be really, really thorough, you would have to like keep running until you've run through all possible combinations. So hey, now I have one win. That's great. Let me check out paper. And I lose against scissors, paper again, win against rock, paper, win against rock. Okay, so I get 3 wins. Scissors. I win against paper. Yep, that makes sense. Oh yeah, make sure that you can type all the uppercase versions as well as the lowercase versions. And I'm just gonna quit that. Now, ideally, that's a lot of work to do, and you would want to retest it every time you make a slight change. So that's where unit testing comes in, and that's when you write code that automatically tests your code. It's basically sitting down and doing all of the stuff that I'm manually doing right here to make sure that all your code works. But that's a whole nother topic that I'm not gonna really get into. So why are there 2 while loops? So I have 2 while loops. This is like the main game loop. So that's running like each game, where the player picks something and the computer picks something and it says you win, you lose, or it's a tie. All of that code for one game is in that first loop. But this loop is so that if the player enters, it's so that the player has to enter valid input. So if I run this program again, if I just type random stuff, I want it to keep looping and asking me for valid input until I actually enter something valid, like rock, or R for rock.
You have a new follower.
Hey, K. Cornel, thanks for the follow. Awesome. Yeah, oh, Raspberry Pis. So I used to volunteer to teach this one like Saturday morning kids programming class, and we had to like outfit the classroom. We had like a location. We also had to get like computers for all the kids to use. We thought it's really important for all the kids to have like their own computer uh, to play with. You can like if you're teaching a class, you can like double people up, so it's 2 people on one computer. You really don't want to do more than that, and preferably you want everyone to have like their own machine to work on. And I actually crunched the numbers because with a Raspberry Pi, it's pretty cheap. It's like $30 or something, but it's just like the Raspberry Pi. Um, it is this thing, except you also have to buy a case, and that'll be like another $10, and then you have to get like an SD card to fit in. You'll have to get a mouse and keyboard um, to plug in, and then also like a wireless card. And you probably, I don't know, maybe the newer models have more than 2 USB ports, but you'd have to also get a USB hub or something like that because then you want the mouse, the keyboard, and the Wi-Fi card. Isn't there Wi-Fi on board these things? I don't know. These things are like really amazing. And then also you need to get a monitor for it, like an HDMI one, and that was the biggest expense. And then it came down to it was like pretty much just as expensive to get a Raspberry Pi. I mean, it was slightly cheaper, but you might as well just get like a cheap $200 netbook or something like that. But the main reason that we went with getting like really cheap or free laptops that were donated was because laptops are so much easier to set up and take down. Because at the start of the class, we would have like 15 seats, and that's like 15 laptops I have to open up and like plug into power and turn on and make sure they're working. Um, with these, like the keyboard and mouse, like, oh yeah, we did have mice, but that was just like one thing to plug in. We didn't have to like plug in a keyboard, a mouse, and then the monitor as well, and then also power, and then do that 15 times. That starts really eating into your time. So if you ever have to like outfit a class for computers, I kind of recommend like not using Raspberry Pis for that. If you can have like a laptop cart with laptops, that's like the best thing to do. Because it's it really quickens
You
your
have
like
a new
setup and
follower.
takedown. Let's see. Yeah, I think that's it for the rock, paper, scissors thing. Uh, Larability, thanks for the follow. Um, let's go ahead and get to the next
You have a
program,
new follower.
which if you follow that link in the corner, otbor.com/class, that takes you to the class notes. And ComCal95, thanks for the follow. Oh, there is Wi-Fi on Raspberry Pis now. That's great. Is everything in Python encased by indenting? Yes. So Python, this is like the weirdest thing that people always mention if they are learning Python after learning a different programming language. In most other programming languages, you have something like curly braces to show when a block begins and ends. So like here we would have this. The thing about this though is that in those languages, people would also indent their code anyway. It's optional, but it does make it a lot more readable. And Guido van Rossum, I believe he copied this from a language called ABC, which he based a lot of Python syntax on. ABC was designed uh, by some Dutch university, I think, but it was designed as a teaching language to teach people to program. So they purposely made the syntax really simple. And one thing they had was this like significant indentation. Technically, it's different from significant white space. Like, I can have this. This white space can be anything as long as there's at least one space. It's really only the indentation that has to be very specific. And even then, you could have this be 4 spaces, which is like the normal amount, or like 2 spaces if you're really tight on space, or like 8 spaces. Or you could have 3 spaces. Nobody uses 3 spaces. Don't use 3 spaces. That's weird. Uh, Sorry. Yeah, it talks about you can arguments over indentation are also really silly and ultimately pointless. But anyway, let's see. But yeah, so Python uses indentation instead of the curly braces because it can be really hard. Like if you look at a lot of JavaScript code, like the end of it will often look something like this with like a whole bunch of ending curly braces or something like that. And it can look really messy and it's easy to make typos and you're wasting a lot of time trying to like fix those typos. Python actually makes this really great. Everybody always thinks this is so weird that Python has significant indentation, but I've come to wish that like no, every other language should get rid of braces and switch over to this way of doing it. Um, but yeah, a lot of people are like who learn like Java or JavaScript or something. They're just like that's weird. The spaces determines that, but it also like kind of forces you to have much more readable code. Um, right. Okay. We're done with this. We can totally move on to the next program. So if you go to that otbor.com link, which is over there, that will take you to this text file. We're now on rock, paper, scissors always wins. So this is actually, I think I can just modify the existing rock, paper, scissors. This is going to be a rock, paper, scissors game where the player always wins. The program will automatically change the computer's move to make it so that the player always wins. So let's see. Here we go. But first, before I do that, I'm going to shill for all of my stuff. Hey, I'm Al Sweigart. I wrote a book called Automate the Boring Stuff. And the second edition is coming out in mid-November now. It got pushed back a couple weeks. You can totally buy it off of the publisher's website, which is great because not only can... Oh yeah, it has the 30% off pre-order code. Yeah, so that basically lowers it down to basically what Amazon sells it for. But if you get it from No Stretch Press directly, you can if you buy the print book, you get the ebook copy for free. That's the PDF, Kindle, and EPUB formats for free, and they don't have any DRM crap on them, so you don't have to deal with that. It's just a file that you can open and read. It's great. Let me go ahead and post that here. I also have a Udemy course. Uh, so all my books are freely available online under Creative Commons licenses. You can go to automatetheboringstuff.com uh, and just read the entire book right online. This is still the first edition. I'll be updating it with the second edition, but you can go ahead and get started with the first edition if you like. But I also have a Udemy online course, and if you use, let's see in the course notes, this link, this is only good today and like the next couple, like day and a half. You can sign up for it for free. So use the coupon code October 2019 free. That's OCT 209 at 2019 free to sign up for that. So go ahead and sign up for it like right now because you can only sign up for it for free for like the next 2.5 days. It's like Wednesday around noon, I think. Whatever, sign up for it right now. You don't have to take the class like right now. You just get lifetime access and you can take it at your own pace. And with that, I'm going to take a short break and refill my water bottle.
You have a new follower.
Hey, new follower, Edga, thanks for the follow. And I will be right back in like a minute and a half. You won't even realize I'm gone. Yes, you will actually, because nobody will be sitting in this chair. But I'll be back soon.
You have a new follower.
Hello, everyone. How's it going? I have a really dark secret, and that's I'm really addicted to these peanut butter cover pretzels with the peanut butter on the inside. I want to stop eating them, but I really can't. Okay, I'm gonna like shove it away from my desk so that I can't like reach for it while I'm streaming because it's really obnoxious to like make chewing noises into the microphone like this. Oh, so good. Yes. This guy knows what I'm talking about, by which I mean Radio Sketch, who made the post that they're so good. They are so good. Um, right, let's do this. This is like I got the idea for this from that like Twilight Zone episode. The Twilight Zone episode with the gambler. There's apparently a lot of these. It is like the Twilight Zone, or maybe it's Outer Limits. Oh yeah, it is. Yeah, the gambler who like dies and and then like wakes up in the afterlife, and then he's in a casino and he keeps winning, but like he can only win, and then the thrill of winning is now all gone. I think this is like before he dies. And then he realizes, oh, he's not in heaven where he wins all the time. He's actually in hell. Uh, and apparently he falls out a window. I don't remember that part. Wait, is this the episode even? Maybe this is like a totally different episode. I'm just rambling on. Um, Anyway, yeah, so let's make that. This is going to be right here. Let me copy this, open it up here. And just temporarily, I'm going to paste all that code in. So this is what the game looks like if we run rock, paper, scissors right now. I guess, really, let's do this. Do it and save it as rock, paper, scissors always wins. So this game looks basically identical to the previous rock, paper, scissors that we just made, except now whenever you make a move, like let's select rock, rock versus scissors, and you win. Yay. Let's pick rock again. Rock versus scissors, and again I win. Rock versus scissors. Okay, let's pick like paper, which will lose against scissors. But no, paper versus rock, you win again. Scissors versus paper. This isn't really a game so much as just like kind of a joke program. Yeah, so it's very similar to the previous program, except now we have something where we're always winning. Cue to quit. Okay, let me open up rock, paper, scissors. Here's what I'm going to do. So this is the original program. I'm going to save that as rock, paper, scissors always wins. So let's think about what we need to change. First of all, guess we don't need these variables, losses and ties, because we only need to keep track of the wins. So now you can see, now that I've gotten rid of those, the linter is pointing out, hey, you use these variables losses and ties, but you never actually define any of those. So yeah, let me get rid of those. Wins I'm going to keep around, but now this is just always going to say 0 losses, 0 ties. Entering the move, all of that's going to stay the same. Yeah, all right, yep. Okay, if they enter something wrong, it gives them instructions and loops back around. Let's say, oh, player move. Yeah, they can choose rock or paper or scissors. The dramatic pause is still there. And then here's what we're going to change. We don't want to use a random move. It's going to be entirely dependent on what the player does. So in fact, I guess we don't really need this random module at all. We can get rid of it entirely. So let's just take that out. And now you can see the linter is now complaining, hey, you don't import random, but you use random right here, so there's a potential problem right there. Yeah, it is. In fact, let's see, how did I do this? Let me...
You have a new follower.
Hey, new followers, Fit Farm and Panzer's to fan. Thanks for the follows. And Trunculent Monkey, thanks for the follow. Oh yeah, just to make this slightly easier to see. Except you always win. Let's add that to the comment right there. And I guess we have to also update this comment right here. And, you know, proper grammar, this variable keeps track of the number of wins. And actually, we simplify this a lot because, there's not going to be ties. And we don't have like three different circumstances where the player wins. It's always going to be wins. We could also like get rid of this. So I could just, cut out all of these, cut out this. Kind of, kind of just like get rid of these also.
You have a new follower.
Yeah, because what I'm going to do each time is just say you win and then increment the value in wins. Um, but hey, so now that I'm no longer comparing, like, changing or comparing computer move and player move, there's no reason I have to do this thing before, so I can cut this out. This is kind of fun, actually. So this program, I'm mostly just erasing code more than anything. So yeah, so I don't have to update what player move is. And I don't even need a variable for the computer's move because the computer is only going to make one move based on whatever player move is. So I can kind of just get rid of all of this as well. I'll still want to, display what the computer chose. So what the computer chooses is entirely dependent on what the player chose. So it's going to be something like if player move is equal to R. Remember, it's just a single letter because we don't update player move.
You
We
have
took
a new
that code out.
follower.
Hey, Jasarski and Speedway Junkie, thanks for the follows. So we have player move equals R. Yeah, so in this case, I guess we want to print scissors. Or else, if player move is P for paper, then the computer move, we don't need computer move at all. In this case, if they chose P, then the computer will choose rock. And if we have player move is set to S for scissors, then in that case the computer chose paper. We can add like a little pause right here. So I think this is it. Yeah, for the most part, it was just reusing the same code that we had before, except if hell win equals true. Hey, Fit Farm, thanks a lot. And choke programs are the only programs I make. Haha, that is hashtag relatable. Yeah, I think this works.
You have a new follower.
Normally when I've already written these programs before, so I'm kind of doing that thing that cooking shows do where they like put the baking pan into the oven and then pull out the finished one that's already in the oven to show. But normally when I'm writing programs on my own, I'm like stopping and running the little bit I've written and testing that, and then writing a little bit more and then testing that, and over and over and over again. Hey, Teddy Bear Junior Bot, thanks for the follow. So I think this works. Let's go ahead and run this. Oh, not that one. It's scissors always wins. Let's do this. First, of course, we still need to test all the same cases. So like, what if we enter invalid input? Okay, that's good. It asks us to enter it again. So let's go with R. Good old rock. Hey, okay, and I won. And that does like make sense. Yeah, rock versus scissors. That means I win. Okay. Let's try rock again. And scissors. Yep. Rock again. This is excellent. Rock with a capital R. Yep, win. Paper. Paper versus rock. And I win again. Paper versus rock. This is turning into like a really short segment for the wow, this was like what, 5 minutes of coding or 10 minutes of coding. Scissors versus paper, and then you win, and so now you're just constantly winning. Oh yeah, let's entering a blank makes it ask us again. Scissors. Yeah. Cool. So this program seems to work. Let's also test quitting. Excellent. So now we've not only made a rock, paper, scissors program, we also have a rock, paper, scissors program where the player always wins. It turns out it's easier to code when you don't actually have to code like a random move for the computer to make. So if you ever want to make video games, just make games where it's trivially easy and the player always wins. I mean, who's going to complain about that? Okay, so let's go back to the class notes. Okay, so the next two games are a bit more involved. These first three were fairly simple. Let's just like crank up the complexity a bit. Not too much though. Remember, all of these programs are still under 256 lines of code, and that like includes blanks and everything. So 2048. Oh man, so this game apparently is so common that DuckDuckGo has their own implementation of it when you search for 2048. Um, and lots of people have made their own clones of this. So I'm just going to use the one on DuckDuckGo. Okay, use arrow keys to move around. This game is it's kind of like Sudoku in that it's just hard enough to like make you sort of think that you're like really figuring things out. Well, I guess Sudoku is like actual deduction. This is mostly kind of just dumb luck. You can move all of these tiles. You can sort of like have a gravitational pull either left, right, up, or down. So let's say I go right. Oh, okay, there we go. I had to click on it first. I go right, and it'll create a brand new tile each time you move somewhere randomly. So what you want to do is move them so that the same tiles run into each other. So if I move up, this tile and this tile will move together, and then they'll combine to form 4. And now like this new 4 tile has come up. So I'm going to move, how about I move left, and these two will smash in together here to form 8. Okay, so now I want to combine these two 2s, because you don't want the board to fill up. So you're constantly having to combine tiles, otherwise it'll just like take over everything. I know I can move left, and then a new 2 has appeared here, but I can also move down. I don't think there's any way I can combine these 2s. So how about if I just move them up? Oh, then I can move this down. I can move right. I can move up. Those 8s have combined. And now I need to combine these. Hey, that was like a twofer. I combined those 2 4s into 8 and the 2 2s into 4. Yeah, and so eventually you want to go to like 16, 32, 64, 128, 256, 512, 1024, 2048, which is where the game gets its name from. And once you get to 2048, you win. This is kind of, so it's like what, 11, step 2 to the 11. Yeah, it turns out you can actually just like kind of make random moves and do pretty well. So I'm just like making random moves. So, I mean, I'm clearly going to fail, but it takes a surprisingly large amount of time before I actually fill up the screen. I am literally just mashing the keyboard. I'm really surprised I haven't lost yet. I've gotten up to 256. So yeah, it's a puzzle game, and it is kind of hard to actually win, but you can get surprisingly far before you actually fill up the entire board. So we're going to make a text-based version of this game. And that text-based version is right here. So let me post this into the chat room. Oh yeah, you probably can. It probably doesn't stop at 2048. It probably lets you continue going for as high as you want. But I think 2048 is like the generally understood, okay, you've won, you can stop now level. Oh yeah, divine insanity. Yeah, else elif is basically means else if. Um, um, so like this code runs. So Python will run this code and it checks, hey, if player move is equal to r, run this code. But if this is false, uh, go on to this, and this is saying, or else if this is true, then run this code. And if that's false, go ahead and say, or else if this is true, then check this code. So only one and only one of these blocks will ever execute. It's the first block that has a true condition. That's the one that gets executed. The rest of them get skipped. And then finally at the end, you could also have just an else. And this would basically say, hey, if every condition previous to this has been false, just do this block by default. But we don't actually need that in this case. So let me go ahead and now I call this game 2048.py because if we ever wanted to import the code from this, this is actually a little thing about Python syntax. We could do this game import game 2048, but modules themselves can't just be numbers by themselves. So I can't name this 2048.py because Python's going to complain about this syntax. It's going to say like, oh, hey, you can't just import a number. Like that's not a variable name. The other time that this comes up is if you ever have, like if we had named this game dash 2048.py, we can't import this either. So you don't want to use numbers only. Like the file name that you use, whatever.py, also has to be a valid variable name. But file names themselves can be things that aren't valid variable names, like this dash. This kind of like Python interprets this as like variable minus this integer. So anyway, that's why I'm calling it game 2048 instead of just 2048. But anyway, we're not going to import itself from this. I'm going to just, oh, not that. Instead, select all and paste. So you can see like this 162 lines of code. It's really not that big. And when we run it, you can see we are using like ASCII art. We're just using like these pluses and the pipe character and dashes to draw out lines. And then we're using the WASD keys. If you've ever like played video games, you know this. If you haven't, so if you look at your keyboard, the WASD keys are in the same formation as the up, left, down, and right arrow keys on the keyboard. The thing is like I can't like enter arrow key presses as text characters when I call input to return. And also, it's kind of nicer to be able to use your left hand. Well, if you're right-handed anyway, for these moves. So that's why the WASD keys are commonly used as sort of like the left-handed arrow keys. But yeah, so we start off with two tiles, and I believe I add a new 2 or something. I forget the exact rules that this uses. But yeah, I could type in W, and what you can see is we don't like erase anything on the screen here. We just print out new text. So we print out a brand new board every time we update it. So the thing about these text-based games is that, we have like the graphics are basically just ASCII art because we use like these little text characters for all the drawings. But also we can't erase previous things that we've printed. We can only print more things out. Which is like meh, but also like not that bad. These constraints really force us to be creative with how we write our code. So we can see it's also kind of nice because I can scroll back up and actually see what the previous states were. So these two both went up and formed this 4, and then this 2 is a new tile that appeared. So I could say D, and that moves everything to the right. If I say S, that moves everything down. And then I could say, let's move to the left to combine these two twos into a 4, and then let's move up. So W to combine those 4s into an 8. And like right, left. Yeah, and then I could just keep doing this over and over and over again. I'm just like doing the same up, left, down, right pattern. And I'm doing startlingly well using this strategy. Oh, whoa! Oh, this is interesting. Oh, I'm gonna have to fix this. But I'll do that probably after the stream. Oh, if I enter multiple, yeah, I didn't test this thoroughly when I first wrote it. So if you enter more than one character, that causes an exception. So I'm gonna add that to my little notes right here. Okay, but you can see eventually we'll either win. Actually, I don't think I have like a win state for this game. It just keeps going forever. No, that can't be because eventually like the number of characters will be way too big. It must stop because like you can only fit like so many numbers, so many like digits in here. Um, Here, let me go ahead and I know how this program works, so I can just start messing around with this. Um, oh, I have like a to-do comment here. Yeah, I guess I'm not completely done with this. Do 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 do. Add to board. Tell you what. Let's add 16. Let's call this 16 times. Oh, this is after the move. And then that just breaks it kind of. Whoops. Okay. Get new board. Oh, this is actually really hard to test. So okay, I can make it so that like we add 15 twos to the starting board, but like as soon as I move them all down to the right, like half the board goes away. So it's actually kind of I'm back to it's I want to test the game over state, but that's actually kind of hard to do. How about if I just move up or down? Yeah, that's good because that makes them stack up a lot faster. Okay, and once the board is completely full, now it actually says game over. Okay, so let me oh, erase that code. So yeah, this is the entire code. We can see how it works here. Let me catch up on chat. Is there a way to clear the screen between moves? Yes, there is. Technically, I don't do it because I know in some of the games in that collection, yeah, I have this one folder terminal, and let's see if we go to the repo. So here's all the repos. Let me post this to chat. Oh yeah, I guess. Yeah, I guess. Oh hey, there is a thing. Yeah, I think in the interest of keeping the code simple, um, even though you could make a move, I just have it where like as soon as the board is filled up immediately, then it's over. Really, what I should do is wait. Well, I could wait until after you make a move, and then if the board is already filled up, and then it tries to add one more, then it ends. But then you could also be in a state where the board is filled up and you can't make a move, so you end up having like make a move anyway, and then it will pardon me. Um, yeah, I think in the end I've had to make some adjustments to these games to make them fit into like as little code as possible. But yeah, you're totally right. I guess that's something I could like. I'll leave that as an exercise for the reader. Let's see. So here in this the Python standard IO games repo, source is the folder that contains everything, and then I have Bext is this Bext is a module that I created that's built mostly on top of Colorama, um, but it adds like text with color. Uh, but even if you don't have that, you could use terminal, which I'll use this Fireflies thing. So this does clear the screen with a function right here. So the thing is, though, that this only works in the terminal. If you're running this from like PyCharm or Sublime Text or something, this is going to be meaningless and doesn't do anything. So it's like I feel like it's kind of cheating. I'm going to kind of with the thing with like print and input, which basically use the standard input I/O streams, the standard I/O streams. Um, you can spit out characters to the output stream, and that gets rendered on the screen. But you can't like move the cursor around the screen. For that, you need to do other things like have the Bext module, or there's another module called curses, um, which like back in the days of like MS DOS, when you or like if you've ever played the game Dwarf Fortress or NetHack or something, those are the sorts of games where they erase the screen or like redraw characters, but they're still using text characters and colors. They don't have like per pixel graphics. Um, those were the types of games that used curses. Um, but in the interest of making these as like portable as possible, and also only rely on the standard library, I tried to not use those tricks. So that kept me from like clearing the screen. However, you could always just run the CLS command on Windows or the clear command on Mac and Linux, and that does the same thing as this. When I type CLS right here, it clears the screen. So you can't really get a very high FPS doing this, but you can get like surprisingly well as long as you're not printing too many characters to the screen. So if I do, oh whoops, yeah, GitHub/Python standard IO games, source terminal. I can run like this Fireflies program. So you can, the flicker is pretty bad. I think it's like the best I can get is like 10 frames per second. You don't really notice it that much because it's just printing out periods and then occasionally these squares. But this is kind of nice. It's basically drawing out the entire screen and then it's clearing it and then redrawing it. But yeah, without something like curses or just using the CLS command, it's really flickery. What else was there in this folder? Oh yeah, Conway's Game of Life. So again, this is like kind of cool, but you can definitely tell that flicker is there. So yeah, in the interest of like trying to keep these games as simple as possible and also as portable as possible so that you can translate them to other programming languages, because all programming languages have standard I/O. They all have their own version of print and input. I wanted to keep this like not relying on third-party libraries like curses or anything like that. So let's go ahead and get started. This is kind of a complicated game. Let's pretend I didn't have any of this. So first things first, I'm going to type out little credits here by Sweigart. Give my contact information for anyone who finds this, a little description. This is like a sliding tile game to combine exponentially increasing numbers. And then I'm just going to copy and paste this. Next part, I like to have like a little bit more background information for some of these. I think this game really took off when this person made their own version of 2048, but really it's sort of like kind of a dumbed down clone of a game called Threes, which I think is a lot less like. Oh wait, no, it's a clone of a game called 1024, which is in turn a clone of a kind of clone on this game called Threes, which required a lot more strategy. But 2048 is the one that was like, it was the Flappy Bird of its week. Okay, so let's think about this. We're gonna need, let's import things. That's always a good starting point. We have tiles appear in random places, so we're gonna need the random module. And we also are gonna need sys.exit because we can also quit whenever. So this is one of those cases where let's think about the data structure that we're gonna use. So how can we represent... Oh, I wish I hadn't actually... pretend I didn't type all this. Let me run pi... And then Q to quit. Oh, or quit? Control C. Wow, okay, I should add a quit. Let me make a note of that. Control C. Haha, these little changes that I'm going to be making. So how can we represent this board as in a variable? Well, we could use like dictionaries or like a list of lists. A lot of people are really fond of using lists of lists, because then you can have like the index of the list inside them as like the X, and then that inner list as the Y. Actually, I think it's a bit simpler just to use a dictionary for all of these, and then have XY tuples as the keys, and the values are the number in the tile. So let's go back to what I had written before. Let me just save this here in this other file. Okay. So let's start off with this. Let's call this get new board, and this will return a brand new data structure. I'm gonna just type out some like text describing what this does. I guess this would be better as a doc string, but I'm just gonna use comments. I don't want to have to explain to beginners like what a doc string is, so I kind of skipped that. So a board data structure for 2048 is a dictionary with keys of XY tuples, and the values for those key value pairs are of the power of 2 number. So like 2, 4, 8, that sort of thing. Really, I should type all of this in here, but let's see. The coordinates are laid out as... Oh yeah, I'm really fond of using like little ASCII art in diagrams in my comments. So what I mean is I'll have something like this. Like where I draw my own little board right here. Oh, whoops. So I have my x coordinates 0, 1, 2, and 3 going across. And then my y coordinates going down. Here, let me just copy and paste this. I don't need a y here, I just need like a little plus there. And then copy and paste this again, except this is 1. So I kind of have like my own little diagram. I feel like a little picture is worth 1,000 words. And this diagram makes it a lot easier to sort of relate to anyone reading this comment. Like, oh, okay. So the data structure that we use to represent the board is going to be just a dictionary, and the keys are going to be XY tuples, where like an X of 1 and a Y of 2 will be like here and here. So that means it's this tile in the board. Okay, so yeah, there's like a whole bunch of things. I'm gonna go ahead and finish this function and then just try to like broadly lay out the rest of the program as well. So we could say like, okay, the board, that's gonna be a dictionary, but we also need to populate it. So like, it's like if board like 02 is equal to 2, do we make them strings or do we make them integers? I think we should make these integers because we're going to have to multiply them by 2 whenever they combine. And if we use f strings, then we won't have to convert them to strings to make them appear in strings. But yeah, so if we had run this code, then the board should look like 0, 2, it should look like 2 right here. Or, you know, if we copy and paste this like 1 and 1 and set that to 8, then that would represent a board that looks like this. So this function basically just creates a brand new game board, which when we first started playing the game, it's just a blank board, but it has 2 2s on the board to start in random places. So let's do this. We need to go through every possible combination of x and y. So that's going to say for x in range of 4 and for y in range of 4, we can say the xy tuple key in board, let's set this to blank. So what do we want to represent blank? I mean, we could use like 0, maybe like an empty space. I think an empty space is a good idea. Now, we could have I guess, oh, wait, does it not matter? Sorry, I'm looking at my code. It's been a while since I've taken a look at this code. Yeah, let's use like an empty space for this. Now, this is kind of weird. It's like, oh, this is an empty space. Why do we have an empty space? What does an empty space represent? We could make this code a little bit more readable if we just create like a constant variable. Which again, constant, you know, a constant variable is a variable like any other variable. It's just that we type its name in all caps, and it's kind of a convention. It's understood. Don't change the name of this. We just set it once at the very top, and then don't change the value. But instead of having this non-descriptive blank string right here, we could say blank right here. And that means the same thing, except now we can say, oh, okay, we're setting this space to a blank space. So we can forget about the actual details of what the blank value is. We just know, oh, that's the value that represents a blank space, which makes it like decreases our cognitive load that we need to understand this game. Oh, may I ask for the promo code? Yes. Sorry, I'm catching up on chat now. Yeah, so if you go to otbor.com/class, you'll come up with this page. And you can use this link, which I'm posting to the chat room right now. Yeah, what kind of data structures are the coordinates? Oh, so these are tuples. If you don't know what those are, the short answer is they are essentially, let me pop up a new window. They're essentially like lists except read only. So just like you can have a list named spam, 2, 4, 8, or 6 eggs. Whereas a list uses square brackets, and then you can just access any value inside the list, or just change this to be like bacon, spam. And now you can see this says bacon right here. A tuple is kind of like a list. Here, let me ham equals, except you type it using a with parentheses, and you can't modify it, so it's read only. The longer answer to this is well, I gave a talk at Pi Cascades on this. Um, but yeah, of essentially, like, all you really need to know when you're first beginning is like a tuple is basically like a read only list. Um, and in cases where I don't have to modify the uh, the contents, I generally just use a tuple because using a tuple sort of flags this as like, hey, this
You
is
have
read
a new
only.
follower.
Hey, Dougie92, thanks for the follow. Um, and also, I think tuples are slightly faster in certain contexts because Python can make optimizations because it knows that it's never going to change in size. Um, but use tuple because they're the appropriate thing to use, not because you think you can shave off a few nanoseconds or something. Um, but yeah, consider them to be basically like lists, except they use parentheses instead of square brackets, and you can't modify them. So yeah, this is actually kind of people often forget that. Oh, and technically you can't use lists as the keys in a key value pair for a dictionary, but you can use tuples, and that goes into mutability and immutability, which is also a whole nother topic that I can't get into on this stream. Hey, Starkey Blood, thanks a lot. Yeah, wow. Yeah, for everyone else, I've not only written Automate the Boring Stuff with Python, but also a whole bunch of other books before that, and you can also read them for free online at inventwithpython.com. So Invent Your Own Computer Games it kind of covers what we're doing right now. It's basically a whole bunch of text-based games, but it also covers the Pygame module for creating games with like simple 2D graphics. You can find all that in the link I just posted to chat. All right, so here we've set the board to blank. Now, it's this is all really abstract. Like, okay, this dictionary represents a board. What does that mean? Represents. Well, what we're going to have to do is write another function that's like display board that we can pass a dictionary to, and that display board is going to print out all of these ASCII art and numbers and everything on the screen. And that's when it becomes like a bit more real, like, oh, okay, we have this dictionary. It's uh, we create a new dictionary for a new board with get new board, and we can print it by passing it to like a display board, and we can also make all sorts of different modifications and things like that to it. um, but yeah, at the base of it, it's just a dictionary. Now if we were doing object-oriented programming, we would probably create a class, um, but conceptually that's like a lot more topics that the beginner would have to know, and I'm making all of these games for total beginners. Oh, let me get rid of these spaces right here. Okay, so we've set everything to space, but we're not done with this yet. So we'll eventually want to return board, but we also need to set the initial two twos. So let's make like a little comment here. Pick two random spaces for the two starting twos. And so the thing about this is we want to be sure that when we pick two random spaces that they aren't the same space, because then we'll just overwrite the first two with the second two, and it will like um, we'll have a starting board that only has 1 2 on it. This only happens like I guess 1 in 16 games, but still we want to write code that makes sure it doesn't happen. And we can do this using a set. Really? A set? That's what I used? That's kind of complicated itself. So, a set data type is kind of like a dictionary, but you know how dictionaries have key value pairs? Sets only have the keys. Um, so if you had something like eggs, we have a dictionary, like the number of cats I have is 6. One day I will have that many cats. The number of dogs I have is 1. Well, whoops. You know, we can access the value in this key value pair by supplying the key. Um, but a set, on the other hand, basically just has the key. And we could add that, see if we print this out, set, we could add something like, let's add the string cats. And you can see it uses curly braces, but it doesn't have key value pairs. It just has like these keys right here. So sets are really nice if you need a collection of values that don't really require an order, and also all the values are unique. And have add dogs, spam.add, I don't know, 42. That's what this looks like. And then is it remove? Yeah, there's a remove method for taking things out. And then you can always do things like write expressions like, hey, is 42 in spam? And it'll return true or false if that value is in the set or not. The nice thing that this automatically does is that it gets rid of any duplicate values. So like say if I wanted to add cats, the string cats to spam again, that actually ends up doing nothing because cats is already in there. This is just like how with dictionaries, you can have key value pairs, but all the keys are going to be unique. If I try adding a new key value pair that's also cats, then that's just going to overwrite the old key value pair. So sets are like dictionaries, except with just keys, and sets are really useful if you want to get rid of duplicate values, such as duplicate starting values for our 2048 game. So let's create this. Let's create starting numbers, and this will be a set. And the things that we add to this set will be those XY coordinates. It's like say I would do starting numbers dot add, and you know, I want to add something like 0 and 0 or something, but I want these to be random. So this has to be random.randint and some random number from 0 to 3 because that's all the possible x coordinates. And then I'll duplicate that.
You have a new follower.
I'll duplicate that for y. Hey, thanks for the follow, JBJit.
You have a new follower.
Oh, and also Amrothan. Thanks for the follow. So this will add one random value. You know, I could copy and paste this and then add 2. And then if the second one is the same as the first, this only has 1 value in it. That's not technically what I want, because then I would have to run this a third time. But you know what, there's 16 times 16, so is that 200? Yeah, there's a 1 in 256 chance that that would also be the same as the first. So then I would have to call this a 4th time, and this, but you know, I wouldn't want to call this 4 times if the first 2 are already valid. So really, what I want to do is I want to keep running this code as long as there are less than 2 values in starting numbers. So as long as the length of starting numbers, which is basically the size, kind of like how you can pass a dictionary to the length function. As long as this is 2, oh, whoops. Thanks, Linter, for pointing out that I made a typo here. It's not start numbers, but starting numbers. Then I want to keep adding these. So even in like the extreme case where like it picks like 10 starting numbers. Starting numbers? No, this is really starting coordinates. I'm going to make a note to change that. Um, I've already have this like online as starting numbers. I guess yeah, it's really hard to come up with good variable names. Um, because like the number itself is going to be 2. It's the coordinates that we're coming up with. But anyway, until starting numbers has 2 coordinates in it, it's going to keep calling this. So once this has added 2 distinct, and they will necessarily be like different unique values, then this loop's condition will be false, and the loop will stop looping and continue on. Oh right. So we're not done yet. So we have the coordinates, but now we need to add them to the board value. So I guess we could do something like, let's use a for loop, because we want to loop over the values inside of some container value. So that's usually like a range object. It can also be like a list, but it could also be a set. We could just iterate, for what position, I guess. Yeah, this should be like starting positions, really. But anyway, for position in starting numbers. So remember, starting numbers contains a tuple of 2 integers, and that's going to be like our x, y integers. So we can grab each of those, assign them to position each time we loop over this code. And so we can say, hey, position for board position, let's set that to 2, because the starting numbers are going to be 2. And then we finally return board. Okay, so let's go ahead and run this, which so far it's going to do nothing. It's going to import these modules, assign blank, and then define this get new board, but it doesn't actually run any of the code in here. But that does mean we get to run this. So we get to call this ourselves. So get new board. And you can see there's, so we have all 16 spaces here. This is a dictionary value that we can tell because it has curly braces and these colons for the key value pairs. They're all set to blank, which is this blank string right here. Yeah, it looks like all of them except for 1, 1, and 1, 2. Now technically, we don't have to print out a fancy, we don't have to print out a fancy ASCII art board like this. This text right here technically contains all the same information that we need, but for us humans, it's way easier to reason about information when it's presented to us like this rather than like this. This is like I'd have to, okay, so this is like 1, 1, that's like kind of in the like diagonal, and then 1, 2 would just be the one below that. So those 2 are set to 2 and the rest of them are blank. So I guess I could move it up or down. Is that? Yeah. I don't, anyway, that's really silly. Let's go ahead and write a function that takes dictionaries that look like this, and it prints out a good-looking game board like that. Whenever I'm making these like tiny little text-based games that have some sort of board, the first things I do are like figure out what the data structure I'm going to use to represent the board looks like, and then I create a function that generates like a starting board, and then another function that I can pass board data structures to, like the board as in like board game. Board isn't like a technical term or anything. But I'll create like a draw board or a display board function to render it on the screen. That's usually like a good starting point. There's so much more to this than that, but that's a pretty good starting point. So yeah, let me do that. I'm going to create a new function. I'll call it draw board, and we'll pass it these dictionary objects, and we'll reuse that name board here. Remember, this is a local variable because it's a parameter. We're just passing any dictionary that is formatted like this, and this function will take a dictionary like that and display the appropriate amount of text on the screen. So A way that we can kind of cheat and do that is by using the format string method. So remember when I was talking about like f strings and then that weird %s way? There's actually another way that you can, like, in the beginning, Python had that %s way of doing string interpolation to put strings inside other strings. And then there was the format string method, which I'm going to show right now. And then there was f strings. I really wish that f strings had been like the way that it was always done, but oh well. This is actually kind of nice. Let's say we have a string there. Let's say my name is set to, whoops. Tell you what, okay. Name is set to Al. And I have a string like hello. And I want to interject like the name right here. I could use like these curly braces right here. This is not an f string. I don't have like the f prefix right here. But I could call the format method on this string and then pass a variable like that, and that evaluates to a string like this. There's a ton of nifty features if you figure this out, like job equals writer. You can say blank is a this dot format. I could pass like name and job here. Al is a writer. There's also like all sorts of fancy things, like you can swap. You can add indexes inside here, and that refers to like the indexes in this. If like for some reason you had like a list of values that you wanted to pass in, which is kind of what we're going to do for 2048. So this is the job of blank, and so writer is the job of Al. So even though this is name job, we can have this as job and then name. There's a whole bunch of other things. You can look at the official Python documentation for the format string method, which basically would look like this: Python format string method. Oh, and you just find a whole bunch of things. Yeah, here's the official documentation. There's probably like a Stack Overflow. Yeah, here. Oh, this is good. Like, hey, when would you want to use the %s thing versus the format method? That's probably actually pretty useful right there. But yeah, just Google it if you want to learn more. The second thing that we're going to do is we're going to use multi-line strings. And that's a string that begins with 3 quotes or triple quotes. It can be 3 double quotes or 3 single quotes. I tend to use triple quotes. But if we have text right here, it ends with another triple quotes. But the nice thing about these strings is that they can be across multiple lines. Like otherwise, if you didn't have triple strings, you would have to use this /in for a new line character. So let me just display what that looks like. Hello /in world. However, if you use a triple quote, notice how it's like showing the ... because it's waiting for me to finish that triple quote before it accepts it. And then you can say hello and then a bunch of new lines world. You don't have to type this /in everywhere, which is going to be really easy, or make it really easy for us to write out what we want the board to look like. And you know what? I'm not going to type this. I'm just going to copy and paste it from this. Bam. Now there's going to be some changes that we have to make because we have to like insert the numbers for the tiles here. So we make this a bit more consistent. So here we have all the blanks right here. So this is 1, 2, 3, 4, 5 spaces. And so this middle row right here, we're going to use that to print the number. So I'm going to put those like little curly braces right here, because then we're going to call dot format on this and then pass some more stuff right here. But for right now, we want all 5 spaces in between here to be replaced by curly braces, which kind of like throws everything off, sort of. But that's okay, because when we insert strings in for these curly braces, we're gonna insert the appropriate amount of strings. Because remember, when this prints out, when the number is like 2, 4, or 8, that's a single digit number, whereas 16, 32, 64 is a 2-digit number, and 128, 256, that's 512 are going to be 3 digits, and then finally up at 2048, that's going to be a 4-digit number. And that's when we have the game end, so we don't have to worry about what happens when we get like 6-digit numbers and we don't have enough space for it right here. But I'm going to copy and paste this. Man, so Python syntax is so great, because otherwise we would have to have like separate print. We'd have to repeat print over and over and over again, and then do a whole bunch of weird nonsense or something. But this is going to be really easy. So now we need to pass something here to fill in all these values. And we can't just pass board, because this is a dictionary and the format string method isn't expecting a dictionary. It's expecting like a whole bunch of values, like 2, 4, 2, that blank string, to another blank string. And it's going to require 16 of them,
have a new follower.
we have 16 curly brace pairs right here. So it's going to expect this, which brings us to another Python trick. So let's say we wanted to print out cats, dogs, mice. I can pass this as 3 separate string arguments to print, and print will automatically put a single space in between each of those arguments that we pass to it. This is kind of nice, because if we had, I don't know, pets. Oh, also, Lambo78, thanks for the follow. But let's think about this. What if we had these values inside of a list like this? We can't just print out pets, because that's going to print out all of these commas and quote characters. If we want this, we'd have to like change that around. However, Python does have a way that you can take a list with values and then pass those values as though you were passing them individually to a function. And it's by doing this, you have an asterisk right at the front. So this is saying, hey, don't pass the list pets as one list value to print. Instead, forget about the list, just take out the values inside the list and pass them as though you were passing them individually to print. That's what this single asterisk means. It's pretty sweet. And so now you can see, like, oh, we have, it's almost, this is the exact same thing as this. So we're going to do that here. We're going to create a list called labels. And then we're going to pass the arguments, the values inside labels individually to format for each of these. So I guess labels will have to be a list value. And remember, we can't pass board. Board looks like this. It's a dictionary. It has all these weird XY tuple keys in it. Format doesn't really understand that. So we have to translate between this and just a normal list with just the values in these key value pairs, like right here and right here. Further, on top of that, we have to convert these to strings that have appropriate amounts of spacing on the left and right side, so that they're always like 5 characters long, because that's how many of these dashes we have right here. So that's kind of a lot to keep track of. So let's do this. So we have to do this in order, going from left to right, top to bottom, because in this string, that's how we encounter these curly braces. So really, I kind of want the labels to look like this: board 00, comma, what we're increasing x, so that first one, till we get to 3, and then we go back to 0 for x, but we go to 1 for y, and that will be this curly brace right here. This is kind of getting, we're going to have 16 of these. That's, we could totally do it. I mean, 16 isn't that much. We could just hard code it like that. In fact, maybe I should hard code it because this is a lot easier to understand. And then just cram all that in there, maybe? I don't know. Let me make a note, just hard code. I think it would actually be a little bit easier to just have a loop instead. So let's loop through all the possible y coordinates first. So range 4, that'll go from 0 to 3. Oh, hey, I should catch up on chat. Do you ever have streams for people who are more intermediate, like classes and objects? Oh, no, not really. I mean, I kind of considered this to be sort of intermediate level, but I mean, you're right. If you'd rather learn like object-oriented stuff, not really. Most of the stuff that I've been streaming has been either like projects that I'm working on, or these sort of for beginner games as I've been making them. Like there are a lot of past streams of me originally creating these games. This is just like a class that I'm doing and will post to YouTube afterwards as well. But let's see. Yeah, so, okay, let's see. We're looping over all the y positions. And now we're looping over all the x positions as well. And then we will append, let's see, well, it would be nice to just do this. And this is the right order, right? Because x is changing, so like y will start out at 0, x starts out at 0, then x goes to 1, and well, y is still 0, and then x goes to 2, x goes to 3, then x will go back to 0 because we'll loop here, and y is this. Yeah. This is what we want to do. If we had this code like this, I think it would end up drawing it like kind of flipped around. And of course, we don't want to print out the coordinates here. We want to print out, we don't want to print out this coordinate. We want to print out the value for that. Man, this game is a lot more complicated than I thought. Maybe it's not for beginners as much as I thought. But anyway, we want to do this because we want to print out the value in this dictionary for that key. But then we don't even want to do that because remember, we need to have this be 5 spaces long and also, in the center, like have this 2 right here. So we can do this. This is going to be either like a blank string like this, or it's going to be an integer value like 2. So luckily there is a string method called center that will add enough padding with white space on either side to put some text in the center. So if I have an integer value like 2, I can pass that to string, but then I can call the string method on that string, and what is this, 5 spaces? And it'll say, hey, okay, this is this string has length 1. That means in order to make this 5 characters long, I need to add 2 spaces to the left and 2 spaces to the right. If we had something like 16, I guess it favors adding more spaces to the left. So it adds 2 spaces to the left and 1 space to the right. And so this will work all the way up to 2048. Adds just 1 space. Here's the other thing though, for our blank tiles, this will also work on a blank string. It just adds 5 spaces. So the end result is that we always have a string that is 5 spaces long, which is good because we want each of these curly braces to be replaced by something that's exactly 5 spaces long so that the rest of this lines up when we print it out. So okay, so remember this is going to be like either the blank string or an integer, so we need to convert that to a string. And then we need to call center 5 on that string. Man, I should really break this down. This is kind of like a lot for one line of code. Let me make a note to myself. I don't know, like as you get more experience, you get used to like thinking several steps at once, and so you end up writing lines of code like this. But even when you're more experienced, when you have to like go back and look at this code and think like, what does this do exactly? And it's like, oh, string, convert to a string, center, 5 spaces, star, labels, format. This is why I should add, I think I've been meaning to add more comments to this game actually. This probably wasn't a good selection.
You have a new follower.
Hey, Geekly Times, thanks for following me, despite the fact that I write inscrutable code. Oh man, yeah, I think that's it. Okay, so let me do this. Let me print out the labels string. This will just, you shouldn't do print debugging where you just like print it and then you run it, because that's like bad. You should use like logging instead. But as a nice, it's sort of like global variables. Yeah, in small amounts, it's fine. It's like a quick and easy way to get this done. So what I need, let's call get new board and save it to B. So this is going to be a dictionary. I guess the 2's are now at 0, 3, and where? Oh, and 1, 2. So now we can call drawBoard and we'll pass B to this. And it prints that out. And it also prints out some debugging information. Here's what that labels list looks like. So it's as though we, instead of like labels right here, it's as though we had passed this list there. And so this string gets put in this curly brace, and this string gets put in this curly brace. And this will pad it out so that this line actually matches up with all the other lines. Yeah, totally. This will be saved as a video on demand, and also I'm going to be posting it to my YouTube channel as well after I like clean up the audio and other stuff. So that's great. Okay, here's the reason why print debugging is bad, because you have to go back and then like take out the prints that you added, and you might accidentally leave them in, and that can become a pain. But it is a really simple way to debug your code, so that's why I'm doing it. So cool. So hey, notice how like this is that board diagram. We can change what this dictionary, this board dictionary. Yeah, so we can change this board dictionary. How about this? 0, 3, that's currently set to 2. We could set this to 32. And now when we display this board, we can see like, oh, okay, that coordinate is now set to 32. But more importantly, when we call drawBoard and pass that dictionary, it's now set to 32. So now we just have to write a bunch of code that modifies this dictionary data structure of the board that represents the board, and then we can make any changes that we want. So, like, say if we
You
wanted to
have a
move
new
everything up,
follower.
I guess, what would that involve? We would have to, let me print out B. Um, I guess I would have to change, like, B 0, 0 would have to equal 32, and B 1 and 0 would have to equal 2. But I'd also want to get rid of the old ones, because if I call draw board with this, I've just duplicated these. So I need to get rid of these by setting them to blank strings. So that's what? 0, 3, set that to a blank string. And 1, 2, set that to a blank string. And now when I call board, it looks like, I mean, this is kind of like a sleight of hand trick, but going from this, going from this board to this board, it looks like I've moved all the tiles up. So we have to write code that manipulates this data structure in the ways according to the rules of the 2048 game. Man, this is like super complicated. I really need to go back through this and like simplify this code a bunch. But okay, let's continue on. Oh yeah, and by the way, you can also follow along with this code right here. Let's see, do I use any extensions for Python or Sublime Text? Yeah, I have plenty of extensions for Sublime Text. Browse packages. I think the main one that I use is Sublime REPL. And then I have it set, there's like another plugin for Sublime Text specifically for the Python syntax, which uses PyFlakes for the linter. Oh, this is Sublime REPL. That's so that I can get these interactive shells. And then there is like Sublime linter or something like that. Oh yeah, an origami, but I forget. That has a bunch of features that I keep forgetting are there. Yeah, Sublime linter and Sublime REPL are the two two plugins for Sublime Text that I usually use. Okay. So let's do this. What are the different things that we're going to have to run? Let's see, make move, and we'll pass a board dictionary to this, as well as move, where like move is one of those WASD characters to tell it the direction that it's moving. I'll just put a pass statement right in here for right now. What are some other things? Oh yeah, we'll need some things like, get the player's move, so that they can like enter if they want to like move WASD or quit. Let's see. Oh yeah, every time that the player makes a move, a new 2 tile is added at a random place on the board that used to be blank. So let's make a function that does that. And also, we need to check if the board is full, because if the board is full, then we know that the player has lost. Oh, and as like a little helper function, this will probably be called by make move. We need to add something that like squishes column. Actually, I'll enter that later. I'll worry about that when we get there. Cool. And then we're going to have the main part of the program. So this will be, so we're defining a whole bunch of functions that will be called by this main part right here. Let's just have like a little intro, the 2048 game. by Sweigart. And then let's create one global variable that will contain the current game board. So I'm going to call that game board just to make it distinct from like board. That way we don't have like a global board variable as well as all these local board variables. Makes it a little bit easier to reason about. So always a good plan. We have a main game loop. And let's see, what's the thing that we do over and over and over in this game? Well, we display the board. We get a move from the player. We'll then calculate the results of that move and change the data board structure. And then probably like, oh, and if it's a game over, then we'll we'll call sys.exit and terminate the program. Or if we've won, then we'll also terminate. I don't actually think I have a win state in this program. But let's go ahead and try this out. Yeah, so, well, we could just do all this code, draw board, and we'll pass it our game board structure. We'll want to call get player move, and we'll save the return value in player move. So player move is something like W or S or whatever. I'll improve these comments later. I'll improve these comments later. That's something that I very commonly say and sometimes also follow up on. And then we want to do this. We'll call make move, and we will pass game board to it. And since game board is a dictionary, and dictionaries are mutable values, which is like a whole nother topic. Just we will, yeah. Actually, here, let me do this. Make a note for myself. Have make move return the board. Yeah, we'll just say we'll make the move. This will modify the dictionary in the way that the specified move. Oh yeah, pass player move to it. So this is kind of like the skeletal outline. All the main meat of this is going to be in these functions right here. But I kind of have an idea of the parameters, the input to these functions, and then the return values. So I can write all of this code fairly easily. Check to see if the player has lost. So we can say if, and we'll call that is full, and we'll pass it our game board. And so if this returns true, then we know the player has lost. So we should, let's draw the board one last time, because they haven't seen what the board looks like after make move was called. And then we'll just print out game over, thanks for playing. And sys.exit.
You have a new follower.
Hey, hey, Hangman's Moose, thanks for the follow. Why is this complaining? Oh, the linter is complaining because I'm passing an argument to is full, but there's no parameter there. That's because, yeah, is full, this should have a board. And add to board, this should also have a board passed to it. Get player move doesn't need anything passed to it. Oh, right, and I should also add 2 to the board at some random place. So let's say game board, add 2 to board. And to which board? To this board that I'm passing to you. Great. Okay, checking up on chat. Where are the functions called? Is there a main? Are all functions called simultaneously? Oh, no, that's not. That's actually not a dumb question. It's a really common one. So, you should always think about this as with Python. Yeah, because like in C and in Java, there's usually like a main function, and that's what's called the entry point. If you've ever made Android apps, those can have like several entry points based on like when you first start the program, or like if you like turn your phone back on from a sleep state or something else like that. For Python programs, though, you can just think of it as starting at the top line and then just going down. So this is a comment, so that's ignored. This is a comment, that's ignored. This is a blank line, that's ignored. Uh, and then this is the first thing that gets executed in this program. It imports the random and sys module. Then it assigns a blank string to this constant. And then here, so the thing to keep in mind is that this doesn't call the getNewBoard function. This defines the getNewBoard function. It's kind of like the equivalent of an assignment statement for a variable. So after this point, now it's not gonna pay any attention to the stuff inside this function. So it's gonna skip down here, which is a blank line, and then just define this next function. So you can only call a function after it's been defined, which is typically why in a lot of Python programs, like the main part of the code is at the bottom. What people also sometimes do is they put a main function at the very top and they put all this code inside that main function. And then here at the bottom, after all of these functions have been defined, then it calls the main function. And that's just kind of like a style choice. It's kind of nice to have this main function at the top sometimes. I kind of just want to make it, I don't know. Actually, in some of these programs, I think I do that. I need to figure out which would be simpler for beginners. But yeah, the main thing to keep in mind is that these aren't actually calling the functions, they're just defining the functions. The code inside them isn't run until they're called, like in these lines right here. Um, yeah, and if we had put all this code at the top of the file right here, we'd get to this part right here, and Python would complain, "Hey, you call a function named getNewBoard, but I haven't defined a function called that because all this would be above this code right here." So that's why we have this set up like that. Oh yeah, it's not necessarily because it's Python's an interpreted language. Um, like that's just like how the Python language is defined. There's no like entry point, so to speak. When people say logic and programming, what are they talking about specifically? Also, they seem to use logic and business logic synonymously. Is it? Oh, okay. So logic is, I don't really know actually. I mean, it is a very vague and general term. I mean, you could go into like Karnaugh maps and like Boolean logic and truth tables. Um, and logic gate functions. I don't think that's what people are referring to when they talk about like logic. Logic is kind of a term that's so general in programming that it's almost useless. Business logic, though, does have a standard term, and it's different from logic. Um, so we write programs not because programming is fun, even though hey, programming is fun. It's really fun to debug all your functions. But we write programs to do something useful. Usually, and if we want to get paid for this, we have to write a function that's useful for like some business or some enterprise that makes money. It helps them make more money, so that's why they pay us to write code. Um, Business logic is kind of like the domain knowledge for whatever business you're writing software for. So if I want to help out Hollywood or something, and I'm creating video editing or like I don't know, Photoshop or something like that, things that like movie companies or graphic designers or something use, the relevant things about their industry that our software has to help them do better, that's like called the business logic. Um, but like in a more common approach, let's say you're writing, like if you ever go to a restaurant and they have those like touchpad things and there's a software where they can just like press down on a table and then do like cash out, and if they're paying by debit or credit or whatever,
You have a
um,
new follower.
things like, oh, you have to write a function that can handle talking to the credit card machine. Um, that is like business logic type stuff. It's very specific to the business of running a restaurant, or like writing a function that can show like the status of all the tables, or or a log like how long like a party of four eats in at this table, so that you can do some analytics or some analysis of it later. All of that stuff is like business logic. It's the information and all the stuff you have to consider uh, when you write software for a particular business or a particular industry. That's basically what business logic means. So, and it's kind of funny because like if you're a consultant and you're writing custom software for some company, then your software is going to be very particular to the way that that company does things, like the way they do inventory or the way they do payroll. Um, so the business logic of their company is going to have a huge like factor in how you write your code, because you're writing it specifically for this rich company that can apparently afford custom software written for them. However, if you create like general like enterprise software or something like that, that's really popular. Say like your Salesforce, um, you can make Salesforce and sell it to a bunch of other people, and generally like, it's cheaper because you can sell to more people. But these other companies have to sort of adjust their processes for your software. Like they have like, widget company X has to adjust the way that they do sales and payroll and whatever to how the Salesforce software works. This is kind of like I'm pulling this out of my head, um, so I'm not sure how great of a metaphor this is. But yeah, business logic is like, it's not like algorithms, like sorting algorithms or something. That's all computer science. Business logic is sort of like, oh, the processes that and bureaucracy that some business has that your program has to sort of follow. Do XFAT. Hey, thanks for the follow. And hey, I've been streaming for 4 hours. I might make this the last program because we did have, I think, like Moncala as the other thing, but I kind of wanted to keep this, yeah, Moncala as the other game, but I kind of wanted to keep this stream at like 5 hours because I'll be uploading it to YouTube later. So I'm gonna go ahead and get back on this. Oh yeah, so this is nice. Well, okay, this won't work because we haven't written this is full function yet, but once it does, we'll have the part where it detects when the game is over, and that part will work, so that's nice. Um, yeah, and I think this is, yeah, I guess we have no win state really. We could write code that does that, but I think I think I was not good enough at this game that it was like kind of hard to actually get to a win state. um, but that's okay. We can still have like a game to play. So yeah, this makes sense. We have a main game loop. We draw the board so that the player can see it. We get the player's move. We implement that move on the game board. Um, like squishing all the numbers and combining them together. Then we add a random 2 tile to the board, so that way we're constantly adding new tiles to the board. And if the board is full, that's game over. We'll also draw the board one last time. But if not, we're just going to loop back over and then draw the board again, get the player move, and do this over and over. So all of this is basically done. We just have to implement this function, this function, this function, and this function. But aside from that, it's basically done. I'll have it done by the end of the weekend. Okay, I'm going to I'm going to start with is full because that's like the easiest one to add. Really, all we have to do is go through every possible space on the board and see if there is a blank value in any of them. If there is, we immediately know, okay, the board is not full because there's a blank there. If we manage to get through all of the possible spaces and we haven't found a single blank, then we know the board is indeed full, so we should return true in that case. So to go through all of the possible spaces, let's go through for x in range 4, for y in range 4. And we can look at this space. We want to say, hey, if this space is blank, remember this is just that constant we have. Technically, it's a blank string, but we've abstracted that away, so it's a bit easier to reason about. If this is blank, then return false, because if there is at least one blank space, is full should return false because it's not completely full. However, if we manage to get through through this entire set of nested loops, and this has never been true, that means every single space is not blank, which means the entire board is full, so we should return true here. Man, so yeah, this is really easy. I should add comments throughout this. Yeah, oh man, I should definitely make this a lot easier to read. Okay. Um, and let's do these two functions. Really, the big pain is going to be this function, because we have to do like all the sliding around and combining things together. That's going to be a lot of work. Add two to board. Let's see. Oh, well, this is basically going to be, we want to randomly select a XY coordinates on the board and then check to make sure that that is blank. And if so, then we set that to 2. Otherwise, if it's not blank, we'll just keep picking new random coordinates. Now, that will cause an infinite loop if the entire board is full. But, you know, the board starts off not full here. We make a move here. Oh, there is a chance that this could be. Oh. I think. Oh, I've just uncovered a really subtle bug with how I do this. Whoopsie. Yeah, sorry about this. I guess this program is not nearly as ready for this class as I thought it would be. Um, hey, thanks, Geekly Times. Okay. So there is a chance that this could, you know, if board is full. Here, you know what? I'll fix that right now. We can call is full board, and if so, we'll just return the board without any changes. Avoid an infinite loop. I should really make this a better comment, but right now, you know, because I'm the only programmer working on this, it's not like somebody else has to read my code, except for all the people that I intend to read this code. Um, you can tend to be lazy with comments when it's just you working on it and it's a small enough program. But you know, if I dropped this right now and then came back to this program 2 weeks from now, I would be like, avoid an infinite loop. What does that mean? How does this do that? Yeah, but I'm also taking notes in a notepad window off screen. Okay. So what I want to do, I want to keep coming up with in an infinite loop random x and y coordinates. So that's going to be from 0 to 3. I'm going to do that for y as well. So board xy, I want to check if this is blank. So if this space is blank, then I want to set that space to 2. And then I just want to return. And if it's not, then I just want it to loop back and find like a different random coordinate. And it's fine if it comes up with the same random coordinates, because then it'll just keep returning. See, that's the problem, is if this board is completely full, this will never be true, and this will never return, and we'll have an infinite loop right here. So to prevent that, I check if the board is full here, and if so, I return. Oh, I want to return the board. Yeah, because technically we don't have to do this because dictionaries are an immutable type, and any changes we make to the dictionary... Actually, oh, that's why I didn't return them. Right. Sorry, dictionaries are mutable, not immutable. That's why I didn't return these. So I'll do the same in make move. Because otherwise that would imply that they are immutable, and then when readers find out that the changes they make to a dictionary inside of a function are also changed in the global scope, that would be really confusing. I think it's confusing either way, actually. But yeah, hey, the follow-up book I'm writing for Automate the Boring Stuff actually kind of goes into this, so yay.
You have a new follower.
Hey, Epsilon X2, thanks for the follow. Okay. Get player move. This will be a fairly straightforward function. So we want to print like enter move, and then as a hint have WASD. And we can just call input, but they might type in something that's invalid, so we need to keep looping until they enter valid input. Let's say, hey, move is equal to this. Let's go ahead and convert it to uppercase. So that way, even if they enter lowercase w, it will be consistently uppercase. And let's see, if move in, so in the code I do this, WASD, but this is slightly a problem because, for one, so what I want to avoid doing is having to write code. Let's say move was set to S. I don't want to have to write code that's like, if move is equal to W, or move is equal to A, or etc., etc. So instead I'm just doing move in WASD. That way, if move is set to something that's not in WASD, like if it was the letter X, that expression would evaluate to false. Here's the problem with that, though. If the player types in something like SD, technically this is going to become true because the string SD does exist here. Or if move is set to the blank string, like if they just hit enter without typing anything, this will also be true because the blank string is always in any string. Probably for like set theory reasons or something, I guess that makes sense. Yeah, anyway, college flashback there. So what I should do actually, and this is going to be, sorry, this is going to be a change from what's posted online. What I really want to do is this, like use a tuple and have these as individuals. So now, blank string is not inside this tuple of strings. And SD is also not a string that exists inside this tuple. It's considering each of these values independently. It's not doing like this is technically doing like a substring match and not looking at the individual letters. But if move is set to something like A, then that expression will be true. So this is what I want rather than the code that's online currently. So sorry about that. Man, I'm on the plus side, I'm getting lots of ideas for how to update all these programs. Okay. Oh man, okay, let's so if move is in this, then that's easy. We return move. And or else if it's not in this, then we just want to get them to enter another move. I guess this is also not in the code online, but I should add it. Enter one of W, A, S, or D. Oh, actually, this is also something I forgot to add to the code online. Or Q to quit. So here I can just say, hey, if this is Q, then call system.exit. Maybe add a little thanks for playing. So when this function gets called, it will either return a valid move, which is either capital W, A, S, or D, or this gets run, in which case the entire program terminates. So I have get new board, that's done. Draw board, that's done. Get player move, that's done. Now I need to do, and add two to board, that's done. Now I have to do make move. So this is like the hard part. We have to like reason about what happens when we move tiles in a game, in a 2048 game board, and how should we reflect that in the changes to this dictionary that represents the board. So let me look at, I'm looking at the code that I've already written for this. Right. So I think we have this sort of we sort of have this idea of, I like to break this down into columns. And yeah, I had that, like I said this earlier, I have this sort of like gravity metaphor. So like when we move right, what we're really doing is kind of like setting it as though gravity were pulling everything to the right. So I press right here, and everything moves to the right. And then a new 2 is added somewhere randomly. So if I move down, gravity is kind of like normal. Everything moves down. If I move up, it's sort of like gravity is pulling everything up. Now I'm going to pull everything up, or how about I'll pull everything down, but this time when I pull everything down, these two are going to combine into one tile. And then if I pull everything to the left right here, this will slam down here, and these two will combine into a 4, and that will end up right here. And then this 2 gets pulled by, gravity to the left. So this gravity metaphor is kind of nice. It makes you think of this board not as like a giant board, but as 4 columns. And the way the columns are arranged depends on what direction gravity is pulling everything in. We can think of these as columns, because then we can have like that whole squish combining together logic act on a column, and then we just pass the 4 columns to like a helper function that does that squishing. So, for example, if I'm pulling to the left right here, the first column will be this going across, the second column will be this going to the across, third column is this one, fourth column is this one. The columns are rows if I'm going to the left, and furthermore, the bottom, quote unquote, bottom of the column will be the left side. Now, if I was going to the right, then the bottom of the column would be going to the right. But this idea so like a column only has one direction where gravity is falling. It's always falling towards the bottom, and that way we can have the same logic work no matter which direction we're throwing tiles on the board. So that was really abstract how I described that. Let's turn that into actual code. The first thing that I'm going to do is I'm going to create a little helper function called squish column. And I'm going to make some comments right here. So column is a list of 4 tiles, of 4, let's just say 4 values, either an int of the tile, like 2 or 64, or the blank string. The quote-unquote bottom of the column is index 0 of the list. Tiles always fall towards the bottom of the column. Okay, so and make move is just going to split this board up into 4 columns, and that's but we're going to call squish columns on each of those 4 columns. But all that logic about how the columns are split up from the board, we'll worry about that later. Let's just work on squish column right now. So let's think about this. If a column was set to like 2 blank and 2, then this should, at the after falling, should be what? 4 blank and blank. Yeah, because like these two, they're falling. In this case, since index 0 is always the quote unquote bottom of this column, this 2 would fall down here, and then it would combine with this 2. Yeah, I kind of like this. Let's just come up with a whole bunch of these subjects, right? These examples right here. Now, if this was all blanks, then it would just be the same before and after. Let's say that the 2 was like 1 up 1. Then when, and this is also, yeah, it just has like 1 blank. It's here. When it quote unquote falls to the quote unquote bottom of the column, we want that column to look like this. And then we'll update the board based on the like aftermath of what happens with the columns. So, yeah, let me have like another thing. So like if we were pulling to the left, then this column, even though it's like a row, we would think of this, the bottom of it would be here on the left edge. So that would be represented as blank, 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 and 2. Now if it was going towards the right, it would look like 2 blank, blank, and blank. So this blank right here is actually the left edge because we're falling to the right. This is what the column would look like. The thing is, like, these columns are just one-dimensional lists, so it doesn't matter if they're like on the board, if there are rows on the board or columns on the board, or which direction we're falling up or anything. We're going to split up the board into these columns, and a column, this idea that we have of a column, always has index 0 as the bottom, and these later values should always fall towards index 0. So let's think about how we do that exactly. I'm actually looking up at this at my code and thinking like, how did I do all of this? Okay.
You have a new
So
follower.
note, hey Millennial Gaston, thanks a lot. Index 0 is always the bottom of the column. Okay. So I think before we do any like squishing and combining together of the tiles, let's just make it so that all the numbers fall down first. So, in that case, here we go. Drop all the numbers down into any blank spaces. So if we have this, that is going to look like this. Hey, Davey Carr, how's it going? So the that link that you see in that corner there, otboard.com, will take you to. You're 4 hours into it, but you can still kind of follow along. This will all be on video on demand anyway. You'll see a VOD for it. Do streamers say VOD? I kind of just want to say VOD because it's anyway. So I made a blog post about this online class that I'm doing tonight. I write programming books, the most famous of which is Automate the Boring Stuff with Python, and I also created an online Udemy course for it that you can use this code that I'm posting to chat to sign up for free. But it's only good until like Wednesday on noon or something, but you should sign up and you can take the course at your own pace, so you don't have to like do all the work right now. You can like sign up and then just take it like a month from now or something like that. You'll have lifetime access to the videos. But I've also created a huge collection of like simple games for beginners in Python that are conceptually, well, hopefully conceptually simple enough for beginners to follow along with. I just posted a link to that repo right here, and tonight in particular, I'm looking at these 5, but really just these 4 games. I don't think I'll have time for this 5th one. And just sort of showing how I create this step by step. Anyway, I also have some other links and stuff here. You can read this class notes thing. But right now, I'm in the middle of implementing a 2048 game in text. So, like, the tiles are printed out using ASCII art right here. We use WASD to show which direction we want to go. So D is down. Or no, D is to the right. So this 2 will fall into this 2 and they'll combine into a 4. And that's why we see this here. And then a new 2 tile gets added each turn. And the game ends when you fill up the entire board with tiles. And so you want to keep combining these into exponentially increasing numbers until you get to 2048. So, right, squishing these columns together. Okay, let's do this. Let's create a new list. We'll call it column numbers. And then we're going to iterate over this list, which again is just this, it's stored in this parameter column. So for I in range 4, let me make another note. I should really use the enumerate function in this. But so this starts off at the bottom. So I'm basically going to check, hey, if this is blank, or if this is a number, I want to append it to this column numbers, this new list. If it's blank, I want to skip it. So here I'll append this to, I'll skip this blank, I'll skip this blank, and then I'll append this to. So that'll make it look like this. Column numbers will look like this. And then I can say, hey, keep adding blank values to the end of this until it's of length 4. So that's how we can turn this into this. It doesn't do any squishing together, but it does do the falling logic. So yeah, that seems like a good start. So if column I, oh yeah, we don't want to use enumerate because I do just want the indexes here. So that's of the original column that I'm trying to squish. If this does not equal blank, then, whoops, here we go. Then I want to append that value, this value right here, to column numbers. Now, if this is completely full, that's fine. I'm just going to make an exact copy of this with no blanks whatsoever. But if there are any blanks, then I'll need to append some blanks to column numbers. I'm looking at the code that I wrote and I'm like, oh wait, why did I do it that way? I don't know. For some reason I have this column I, the original column, I'm setting this to blank. I don't think that's actually necessary at all though. I'm gonna leave a comment for myself. Why is this here? Man, this code is not as polished as I thought it was. Whoops. Okay. Right. Okay, so now I have column numbers here. Oh, so what I'm gonna do is I'm going to copy this back to columns. So this is column. From that, I've created this column numbers. And now I think I want to copy, because I'm modifying column in place. It really shouldn't modify column in place though. Okay, making notes for myself later on. Let's do this. For I, and I want to get both of these values, the index, but also the number itself in enumerate column numbers. So remember, column numbers is going to be this. I is going to be set to 0, 1, 2, 3, whereas number here is going to be set to 2, 2, and blank and blank. And I want to overwrite the original one. Yeah, I don't think this code is actually necessary at all. Watch, this program isn't going to work, and I'm going to be like, why doesn't it work? And this is why we should write comments describing like why our code does what it does, so that we don't later think, oh, this code is useless, I'll just delete it. Right, so this basically just copies column numbers to column. And the reason I can't do just this, column equals column numbers, is because this technically doesn't modify this in place. And oh wow, yeah, this program is kind of complicated in that it requires you to know a bunch of Python things, or the way that Python works. Um, because this doesn't modify column in place, it just replaces uh, the list that this column variable refers to the list that's referred to by column numbers. I should really change that. Okay. Why not squish before adding blanks to the end? That is a good question. Why don't I just do that? I don't know. Yeah, technically there's no reason why I couldn't do that. Thanks a lot. Yeah, like I don't need the blanks here. The blanks don't factor into squishing this down into like 4. And then I could just add blanks up to length 4, like blank, blank, blank later. This entire function could be a lot simpler than it is. Tell you what. Well, okay, I don't want to go too off script because if I don't follow the code that I've already written and I try changing a bunch of things, I could be introducing tons of new bugs, and then I would have to change them like here live on stream, and that could become really tedious and boring. Did I say tedious and boring? No, I meant fun. Programming is fun. Everyone should learn how to code. I'm having fun. um, I am not at all sitting alone in my apartment talking into a microphone and an empty apartment. Okay, so next thing. Now I think we want to squish stuff. Right? Yeah. So here, oh, I think I know why, because I'm writing code that relies on the fact that there's 4 values in this list. That's why. Ah, okay, that's why I don't do this. So I'm going to do this. I'm going to loop from index 0, 1, and 2, but not 3. Because I'm going to be, when I'm looking at index 0, I'm going to look at index 1, the one after index 0, and see if it matches index 0, the number at index 0. And if so, I'm going to set this to blank, I believe, and then set this to the sum of these two numbers. And that's how I'm going to get to this. Yeah. Hey, Shankar. This tutorial is not necessarily for beginners, but it's a more like intermediate level. However, all the online course and all of my books are made for people with no previous programming experience. Hey, CX. Yeah, this is a board game. I mean, of sorts. It's technically it's a video game, but you could implement it as a board game. This is 2048. It is this game. You've probably
You
seen it
have a new
before.
follower.
Oh, hey, thanks, Love Hate Masturbate, for the follow. Whoops. Where you try to like smush these tiles together by dragging them and combining them with similar tiles. And they keep going up exponentially, and the idea is that you can eventually get up to 2048. Except we're implementing this using like ASCII art graphics. So what I am trying to do right here is doing the squish combining step. Let's see. So for starting index, in range 3. So I'm not doing up to 4 because I only want to go up to but not including 3, which means 2. Because if I went up to but not including 4, that would be index 3. There's no index, there's no value after the last one. So, there's no possible way the number in this position could get squished down. So let's think about this. Yeah, let me make a note about that. Skip index 3 since nothing can be on top of it. So here I want to say, okay, if column starting index, so if this is the same as the number above it, which will be at column starting index plus 1, then in that case, I do want to squish. So I want to set column starting index, which remember is this one, and we're looking at this one. I want to set this, or really I just want to double it, because like 2 and 2 are the same, so they combine into 4. But like if 4 and 4 were the same, they would combine into 8. It would always follow the logic of multiplying it by 2. And then also on top of that, I want to move everything down. So I'm just going to call this the above index. So it's above the starting index. So that's going to start at starting index plus 1, that space above here, because now that's this is set to like this, but I need to set this to blank. So why don't I just set that to blank? Oh. So like I go from here to 2, and I set this to 4, but this is still set to 2. What I really want to do is set this to this value. So sort of like copy that and blank here, and then set this to this value. This just happens to be blank because I'm moving everything down 1. And then whatever this is, I'm going to set it to blank, which admittedly in this example doesn't look like it's doing anything. But I'm moving everything down 1 and only 1 space, and then adding a blank space at the top. So I want to go up to, but not including 3. Right, because I don't want to go all the way up to index 3. I want to just stop at index 2 right here. So this, setting this. So these are all the indexes above that starting index. So kind of doing that same copy, like the one above it. So this index is going to be set to whatever's above it. And just keep doing that until we get to the end, and then and then finally we want to set the top one to blank. Cool. Let's see if this actually works. And to help visualize this, I'm going to copy and paste this to pythontutor.com, which is a really great visualization tool. So I'm going to paste this function here, and then I'm going to call this function. So squish column. Let's go ahead and take a look, like right here. Let's 2, 2, blank, and 2. So these 2 should be squished to 4, and then everything drops down 1, but also this should drop all the way down there. So yeah, and we only combine them, like these combine into 4, so that, not all 3 of these combine together. We only combine 2 numbers at a time. So the end result of this should be 4, 2, blank, and blank. It all seems clear in my head, kind of, maybe. So let's see if does that actually work? Okay. So pythontutor.com is great. In fact,
You have a new follower.
what it lets me do is I can generate a permanent link, and this will be a hideously large link, but technically you can click on it. Oh, no, wait, you can't because Twitch doesn't let me post comments larger than 500 characters. So let me do this. I'm going to... Oh, and also, Aramis Black, thanks for the follow. What I'm going to do is edit that class notes link. So if you go to otboard.com/class, that URL in the corner, you can now find this. You'll have to copy and paste it because it's kind of a hideously large link there. But you can also follow along on your own computer. Oh wait, there's something really wrong here. Why is this only 2 steps? Blank not defined. Haha, okay, forget that link. Let me go back. Blank equals a blank string. Oh. Visualize execution. Yeah, this 47 steps. That looks more like it. Okay. Which also means I need to edit this again. Okay, so we start off here. Oh, this isn't big enough. Oh, that's so annoying. Okay. Next line, we define squish column. Now we call squish column and we pass this list for the column argument. So you can see here's where the execution is right now, and column is set to this list right here, 2, 2, a blank string, and 2. Now when we click on next, we're creating this new column numbers list. So this is an empty list. And we're going to drop all the numbers. So we're going to basically copy like this, skip this, copy this, or rather append it. So if column I does not equal blank, I is set to 0. This is column, so column I is this 2, and that is not equal to blank. So the execution moves in here and we append column I to column numbers. That's a terrible variable name. I'm really sorry about that. And then we loop over again. So now I is set to 1. We're looking here at this, and that is not blank, so we append that as well. Then I is set to 2. We look at that, and column 2 is blank, so we don't append that. We just go back to the next iteration of the loop. So now I is 3. We're looking at index 3 in column. That is not blank, so we append that. And then we're done with that list. And then oh, I just realized why we do need this. We're copying this to here. That's why we need to set this to blank. That's what this line is for. Because otherwise, when we copy all of these over, yeah, like this 2 gets copied over here, this 2 gets copied over here, this 2 gets copied over that blank, but then we haven't set this to blank. That's what this line, man, this, okay, yeah, this code really does need heavy refactoring. I mean, it works, you can play the game, but it's really hard to understand why the code does what it does. Oh man, so many changes I need to make. Okay, uncomment this. I guess go back here, uncomment it from here. Visualize execution. Generate that link. Let me update the link in the course notes. Great. Okay, so you can refresh this. It changes this link that you'll still have to copy and paste manually because it's just a text file. So let's jump forward a little bit. Okay, so this is, yeah, so here, oh, I see. We append it to this list and then we set this to blank. I think that's what we're doing. Wait, where's the execution? That's weird, it's not showing up. It's very weird. Huh, the little arrow isn't showing. Oh, wait, did I? Oh, huh, I had it scrolled over too far. There we go. Okay, so here's our column. We need to move all these 2's down here. So we do that by examining this. If this is not blank, we copy it over to our second list. And then we set this to blank. That is a really convoluted way of doing this. Then we copy this 2 over to our other list and then set that to blank. Yeah. And then this is blank, so we do nothing about that. Now, I guess that makes sense in a very odd way. Kind of. Anyway, and then this is 2, so we append that to this list and then set this to blank. So at this point, this is going to be entirely blank. And then we copy these values over to their respective indexes. So that gets copied over, and then this number gets copied over. This would have been easier to see if I had picked different numbers. Sorry about that. Okay, now this is the squish and combining step. Starting index is going to loop over 0, 1, and 2. It's going to skip 3 because here, starting index is 0. We're looking at column starting index, which is this one. And if that is the same as column starting index plus 1, so 0 plus 1 is 1, which is this one. So if these two are the same, and they are, then what we do is this line. So yeah, when I click next, it then wants to run that line. Whoop. Which sets column starting index, which is still 0, it doubles that. Bam. So that's how that 2 becomes a 4. But not only that, we need to move everything down one space, starting at this space. So we need to set this to whatever value is here. We need to set this value to whatever is here. And then we skip the last one because there's nothing. We just set the last one to blank no matter what. So that doesn't, it said this 2 gets copied to this 2. That kind of, it's hard to see that. Okay, and then that blank from index 3 gets copied to index 2. And then finally at the very end of it, that index 3 always gets set to blank because we're moving everything down one space. So necessarily the thing at the top of the column is going to be blank as well. Oh yeah, and then we repeat this because there are like additional things. Starting index is now 1. So we're looking if anything above it is the same. But this 2 and this blank are different. So that's why when we click next, it skips all of this and then just goes back here where starting index is now 2. Oh, and technically these are the same. Doesn't that cause it to crash? Oh, it doesn't because this just does string replication, but a blank string replicated twice times two is just still a blank string. So this kind of does absolutely nothing. So it doesn't have like a negative side effect, but that's definitely wrong. We should change this. So if they are the same number, but also, and it's not blank. So we don't care if they're both blank though. Hopefully this won't do something that causes it to just totally fail. But yeah, this is fun. You know what? I'm just gonna leave that as a comment. It works fine for right now. So yeah, let me go ahead and oh, whoops. Squish column. Let me put this in a separate file for right now so that I can play around with it some more. Blank is set to this. So squish column. Let's make sure that this actually does what we think it does. Blank, blank, and 2. So this should create 4 blank, blank, blank. Right, it doesn't, it modifies it in place, so we have to set column here, squish column C, and then look at C. Yeah, so that works. How about if we set this 2, 4, and blank and 2? So these don't combine together. The 2 falls down here, so this should be 2, 4, 2 blank. Okay, that seems to work. What if we had it like this? These 2 would squish down, and then so it would be 2, 4, 4, and blank. Two, four, four, and blank. Okay, great. So this helper function right here. So we've kind of like broken down this giant problem of like, what does the board look like? How can we change this data structure to reflect a move into a smaller problem? And that's with whatever direction these are falling, we split the board up into 4 columns. We make sure that the bottom is the correct way, and then we can pass it to the squish column function. Squish column will do the correct thing. Now we just have to split up the board into columns correctly. And I think I kind of cheat when I do this. So squish column. So that in make move, I'm going to split the board up into 4 columns and pass those 4 columns to squish column. Squish column isn't really a great name either. So, where are my notes? Here. Okay, so I know what I'm doing here. I'm going to say, so here's the board data structure. It's that dictionary. Here's the move. It's going to be W, A, S, or D. So let's say if we're moving up. I kind of cheat because it's only 4 columns and it's only 4 tiles for each column. So I create this variable called all indexes, and it's going to be a tuple. So each tuple inside here, is it a tuple or a... Oh, that's weird. Oh, yes, I do remember this. So these are going to be tuples not of like, these aren't going to be the columns themselves, because that has to be a list. but these will be what the coordinates for each of the columns will look like. So I'm going to have for these inner tuples right here. And so this will be the first column. This will be like the second column. I guess third column, fourth column. I guess it doesn't really matter the order of these columns first. Oh wait, yeah, it does. Okay. Anyway, let's see. And each side inside each of these, I'm gonna have like x, y tuples for everything. So remember the first tuple, the first coordinate has to be the coordinate of the bottom of the column. So if we're moving things up, then what? That means like 0, 0 would be the quote unquote bottom of the column because everything's moving up. So it's like gravity is reversed. It's going up here. The second space, quote unquote above the bottom space would be here, and this would be 1, 0. Is that right? But that's not what I have here. Oh, very perplexing. Oh man, can you post the paste bin, please? Oh, I thought I had the paste bin for what? Because the code for this game is right here in that otbor.com/class link, and I've just posted it. Um, hmm. Very tricky. Okay. I'm looking at the code I've written already, which is this. But I can't figure out just from looking at it. I should really have more columns here, or more comments. So I arrange these indexes into this variable all indexes based on the direction that they're all moving. And then I create the individual column lists based on the board, based on these column indexes. That's a lot of like redirection. um, for moving up. Oh, yeah, this is. Sorry, I was getting my X's and Y's confused. This is totally normal. Okay. Let me. Sorry about all that. I think I just tricked myself because I've been streaming for 5 hours. So, we're moving up. That means we need to split this board into 4 columns. The bottom of the column is going to be at the top here. So let's say this first column, the column should be ordered like this. 0, 0 is the bottom, then 0, 1 is the next one, and 0, 2 is the next one, and 0, 3 is the next one. Then for the next column over, 1, 0 is the bottom, followed by 1, 1, and 1, 2, and 1, 3. So that's why we need to write the code like this. So here's 0, 0. Then we increase the y. So 0, 0 is here, 0, 1 is here. Remember, the first index is going to be the bottom. This is going to be the bottom of this column. And then the next column over, that's going to be follow the same pattern, except the x coordinate is now 1. And the same for the next one, which is going to look like that. And the same, I'm kind of cheating here. For the next one, the column is going to be like that. Now, what if it was the opposite of that? Let's use S. So now we're moving down. Um, so here we're moving down. This means that here, this would be we're still using this as a column, and 0, 3 would be the bottom. So this 0, 3 would have to be first, followed by 0, 2, followed by 0, 1, followed by 0, 0. So 0, 3, 0, 2, 0, 1, and 0, 0. And this makes sense because this column, notice that the coordinates are in the opposite order of this. Here, 0, 0 is the bottom, but here, 0, 3 is the bottom, and 0, 0 is the top. It's the same thing. We're going to need like this in reverse order right here. I'm not going to type it. Instead, I'm just going to copy and paste it. Ooh, line 103 contains a typo. Yes, it does. Really good. Thank you. Oh man, wait, is that typo in the code? In the original code? No, it's not. Okay. Um, hey, it's getting late. uh, wait, is this correct? Yeah, 1 2 1 1 1 0. Yeah, okay. Oh man, thanks so much. That would have like been very trying to like make that typo and then trying to debug it. Yeah, this makes sense. So like while 3 3 is the last one in the last column, it's the first tile in the last column here. Um, and A and D work kind of similarly. I'm just going to kind of cheat and paste this here. Now, just like we're like jumping through a lot of hoops to like generalize this, and that's why this code is kind of hard to understand. Like squish column, like all this squishing behavior works the same way if we think of this as columns, and that's why we can call squish column on every single one of these columns. And then all of this code is just set up so that the next part of this function can work using all indexes. Let's see, I'm just going to start typing this out. So we have 4 column indexes in all indexes. So remember, all indexes is going to be like one of these giant tuple of xy tuples. So like column indexes, if move was set to D, then all indexes would look like this. Column indexes on the first iteration of this loop would be this tuple, which is the indexes for a single column. So let's form, but when we call squish column, we're not passing the coordinates of a column, we're passing the actual value, the actual numbers in that column. But this is great. This code works no matter what direction we're facing because we've dealt with all that weird like direction stuff directly here. There could be like a way to code this that's, uses code or some clever algorithm. This is really, a lot of code, and as you can see, it's easy to make a typo when typing this out. But at the same time, it's a lot more readable and direct. You can sort of see the patterns. You can see the pattern itself. Sort of like how, technically this perfectly describes a 2048 board, but it's in this form, it's really incomprehensible to humans. This form is slightly more comprehensible to humans than some clever like loop or algorithm that generates these tuple of tuples. Okay, column indexes. So we need to make a column. Oh man, I totally cheat when I'm doing this. So remember, a column is just a list of 4 tiles, either like integers or that blank constant. So like column indexes 0, if column indexes was this, then column indexes is this first xy tuple. And then to get the tile at that coordinate, we just run this. So this is a list with one tile, and then here's the next tile, and here's the next tile, and here's the next tile. I'm going to comment this out, and I'm going to write the equivalent of this code, but like make it a bit easier to see. Like if I just say first tile's coordinates, let's say would be this. Then the first tile, which would be the number, would be this. And that means that we could then replace this with this. And we could add like more variables. Indexes 1. Second tile equals board. Oh, sorry. This, silly me. That's the whole reason we do this. So you can see here's like the first tile's coordinate is going to be column indexes 0. Column indexes is one of these tuples right here. And the order, and if we're moving to the left, this is how these are the coordinates of a column moving to the right. I'm sorry. And if it's to the left, it would be the opposite direction. And if it's up or down, it would be different coordinates entirely. And then we say, hey, let's just get this first coordinate. That's what's assigned here, first tile's coordinate. And then the actual tile, like the number at this coordinate is here. And then we construct a column out of that. Man, I am cramming way too much onto this line. That is. So let me make this easier. Third tile's coordinates. Column indexes 2, which means the third tile is board. The third tile's coordinates. Fourth tile. And the only reason we can do this, I mean, this isn't a good idea, but hey, there's only 4 tiles per column. Sure, let's make this a bit easier to understand. I wouldn't necessarily write production code like this, like if I was at a job. But this is supposed to be, well, it's supposed to be understandable by beginners. It's obviously like way too complicated even with all of this stuff, but this will help kind of break it down from a large problem to smaller problems. That's the main thing with programming. I mean, it can all make sense in your head and you can see all the individual parts, especially once you get a lot of experience and practice just taking these things, like seeing a 2048 board and thinking, okay, yeah, we could create a data structure that represents that, and here's the algorithm that would work on that. I mean, this still took me a lot of time to write originally. But like, you can have this highly complicated idea in your head, and then you write down code that does it, but then 2 weeks later, you'll have a problem trying to reconstruct that complicated idea in your head just from looking at the code that you wrote. I mean, clearly, look at how much trouble I'm having tonight. Okay. Yeah, so all these lines of code, it does the exact same thing as this one line, except this is why like one-liners are really kind of terrible and you never really want them in your code. Sure, it fits into a small space in your program, but wow, this is really dense to think through. That's not something that you want to have with your code, because if it's really dense, it's going to take a long time to understand when you're reading it, and you have to read and understand the code if you ever want to make changes for bug fixes or new features. Unless you're just like creating a small program that you never intend on updating or fixing any bugs or anything like that. In which case, yeah, sure, just throw code into the file. It's fine. The computer doesn't care. um, right. Now that I have the column, I want to call squish column, and I pass this column to that. So remember, column gets modified in place, which is also like a bad thing, I think. That's why I don't have like. That's why I don't have. Oops. That is why I don't have code like this. Column equals squish column. But now column is set correctly. However, we need to copy column back onto the board data structure. And oh, I do kind of like split this out. You know what? I'm gonna reuse these. So hey, that first tile's coordinates, we want to set that to the new value in column at index 0. Second tile's coordinates, we want to set that to the new value at index 1 in column. And so on. I can just like imagine people asking like, how did you ever come up with this in the first place? And again, I'm kind of making it look easy because I've already written this, and when I was first writing this, I'm sure I had like lots of like dead ends that I went down. So if I make it look easy, don't take that as a sign that this is actually easy. Oh, right. Uh, Reynolds makes a great point. What if you want to change the size of the board? You don't. Seriously, you would have to change. You basically have to. You wouldn't have to rewrite the entire program, but there are a lot of things that you would not want to do. So, like, that's a good idea. Like, hey, what if we wanted to generalize this to a 2048 board of any size? To which I would argue, hey, 2048 games always are 4x4. That's just like, it's sort of like, you know, hey, what if we wanted a chessboard that was like 10x10 instead of 8x8? It's like, well, no, chessboards are always 8x8. It's not the game of chess if you're making it 10x10. But yeah, if you wanted to do that, you would have to write this code in a much more generalized way so that you're not working with like hard-coded indexes here, which means that your code would end up being much more abstract, and although it would work with boards of any size, it would also be code that's much harder to
You
understand by a
have a new
human programmer.
follower.
Hey, Pastor M98, thanks for the follow. But yeah, seriously, you don't want to change the size of this board at all. Um, let's see. I think this is it. And note, we're not returning board either because we're modifying this dictionary in place, which is also a thing about the original design of this program that I don't like. But yeah, okay. So I want to test out a lot of these functions. So I'm gonna comment all of this out in a giant multi-line string, and I'm gonna run it, which is great in Sublime Text because it runs all this code and it defines all of these functions, but it doesn't call any of them. So we can do this step by step on our own. So I'm gonna get a new board, and the board looks like this, which doesn't make much sense. But if we pass it to the draw board, it prints out a nice little board for us. That's great. Hey, what if I wanted to change this tile? This is what? Coordinate 1, 0? What if I wanted to set coordinate 1, 0 to 4. Yeah, okay, so that works. Um, what if I wanted to make a move on this board in the up direction? Now let's look, and now let's, well, that would make board look like this, which is completely inscrutable, but if we pass it to the drawboard function, it looks like this. That's great. Yeah, and that makes sense. These twos would combine into a 4, but that doesn't, the rules of 2048 have it so that these 4s wouldn't combine. That would have to be on the next move that you make. So we could do that. Let's have it move down, which is S, in the WASD key setup. And now it's 8. Great. Hey, so we're not adding like new 2s to this, which is why that's not happening, but that does happen in the main game. So I think this is everything. Let's test this out. Python game 2048. We have a new board. We're printing out everything. Enter WASD or Q to quit. Hey, let's test out that quit function first. Thanks for playing. Great. Okay, that works. Let's run this again. Let's move everything. Let's try moving everything into all the directions. So D to move to the right. Yeah, that works. And then after all that, we add a new 2. So what happens if we move to the left? A. Yep, that all works. And then a new 2 appears here. What happens if we move down? So if we move down, this one will be here. These two 2s will... Oh, yeah, that's another thing. In this case, we would want the bottommost 2s to combine first. So these 2 combine into a 4, and then this 2 falls down here with a 4 here. We don't want these two 2s to combine. We don't want these two 2s to combine into a 4 and fall down here. So it wouldn't be 4, 2. It would be 2 and 4. Great. Let's move up. Yeah, that works. Left, right, or right, left. Right again, right again. Hey, I think we have a working game. Oh yeah, and if I accidentally enter bad input, it tells me, hey, you need to enter WASD or Q. Let me just try to fill up the screen. Oh, haha. And then game over. Thanks for playing, because the screen is now full. It's done. Ship it. No, don't ship it, actually. I need to add tons of
You have a
comments
new
to this.
follower.
Which I think I was meaning to do with the original program right here. Haha. Gooby, hey, thanks for the follow. But yeah, that's the entire game. And no, this isn't like thousands of lines of code or anything like that. It is kind of hard to put together, and I'm sure if I expanded this more, it would probably come up to about 250 lines of code. But really, like what? All of this is under 200 lines of code. It is possible to make, kind of like clever little fun games in small amounts of code, which is the entire purpose of that of all the games in that Git repo that I'm making. So, wow. Okay, I've been streaming for 5.5 hours. I'm pretty sure my mods are like all asleep by now. But thank you a lot for joining me. I'm going to try to make this into a weekly thing. So I'll probably be back here Monday, 6 p.m. Pacific time, starting with another set of programs, hopefully easier to follow along with. Thank you very much. I'm Al Sweigart. I write books that teach people how to code. And also, I've created an online course that I've been giving out the code, a free coupon code to. Right, and that is right here. You go to udemy.com. You can find my Automate the Boring stuff, and the code is OCT 2019 free. Um, Here is the repo of all the other games if you want to check those out as well. Oh man, Chris, you're still awake. Awesome. Um, yeah, and if you want to find out all of my work, it's on inventwithpython.com. I release all my books under a Creative Commons license, so you can read them for free online. Like you could read, hey, if you like these games, Invent Your Own Computer Games with Python has a lot of like these text-based games as well, and also covers Pygame for games with 2D graphics. But yeah, you can just read it right online, inventwithpython.com. Thanks a lot. I'm gonna eat more of those pretzels with the peanut butter inside of them because they're delicious. But yeah, thanks a lot. Be sure to smash that follow button or subscribe button or whatever. Capitalism dictates that I must do a call to action to have you subscribe or follow me so that you will continue to uh, tell the algorithms that dictate who should be popular that I should also be popular, I guess. No, wait. Oh, God, no. No, I don't want to be popular. That sucks. Um, Whatever. I'm also Al Sweigart on Twitter. And yeah, feel free to email me or message me. And I'll probably be streaming again later this week in the evenings Pacific time. And hopefully I can make Monday night be like a regularly occurring thing where I'm going over some games that I've created and explaining how they work. And so hopefully you can watch along and learn how to code better. Okay, I am way too punchy and tired, so I'm just gonna stop right here. Oh wait, let's find someone to raid. Ha, yeah. Hopefully this part I've cut out of the YouTube video that I'm gonna post. Uh, Great. Okay, Adam C. Eunice, totally. Adam C. Eunice, perfect. All right, thanks a lot, and I'll see you next week or probably later this week even. Do 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 do. Rating in 5, 4, 3, 2,